Welcome. My name is Chris. I'm the creator of AFib, and I'm grateful that you're here. If you're interested in AFib and have not already watched the 12-minute trailer, I'd recommend you stop and do so now. I've placed a link to the trailer in the description. The trailer will give you a good overview of how all the pieces of AFib fit together and will give you more context for understanding the details in this tutorial. This tutorial is broken down into two major sections, Understanding AFib and Building with AFib. In Understanding AFib, we will use the debugger to understand how a simple AFib app works. We will focus on understanding AFib's rendering, state, and navigation models, as well as using prototype mode and AFib's UI and state testing mechanisms. The app we will use in this section is based on one of AFib's standard project styles, so you'll be able to go back and play with it yourself later. The written AFib guide steps you through that process, so there is no need to try and use this video for that purpose. In Building with AFib, we'll build a simple to-do list app from scratch. This second section focuses on using AFib's command line code generation, best practices for building UIs, type ahead conventions, and overall intended workflow from prototyping through production. Let me say at the outset that I made the trailer so that you could quickly evaluate whether you are interested in AFib, and having done so, I took my time with this tutorial. If you find it too slow, I have created YouTube sections, and you can always skip to the next section. This video is intended to prepare you to use the written AFib guide to begin coding with AFib on your own. It will establish a foundation that will provide you with the context needed to understand the full details in the written guide. We will start by creating a new Flutter project and then converting it into an AFib project. You can Google how to install Flutter. I'm not going to cover it here, but Flutter Doctor should report no errors. We will start by using the Flutter create command to create a new Flutter project. I'll call this project Tutorial Eval and cd into the new Tutorial Eval directory. We can start our new Flutter app from the command line with Flutter run, but because we are going to be understanding how AFib works in the debugger, let's go straight into VS Code and open the folder containing the project there. Then we will open the main.dart file. Note that I already have an iOS simulator running, and it shows up in the bottom right-hand corner of VS Code. If I were to click on that text, it would let me select another way of running my app. Let's click on the debug link just above the main function to start debugging. Then I'll bring up the emulator, and the app will start. This is Flutter's default starter app. If I click the plus button in the bottom right-hand corner, it will increment the count in the center. Now, let's convert this into an AFib project. We will switch to the command line and type AFib bootstrap help create. There are three things to note here. First, you would use a different syntax documented in the written guide. Again, I'm running the file locally because AFib hasn't been released yet. Second, the command is named bootstrap because we only use it once to create new projects. After that, we'll use an AFib command that is project specific. And finally, just note that I put a decent amount of effort into providing good help on the command line, so remember that it's available. So let's run the command to convert my Flutter project into an AFib project. I am in the root folder of my Flutter project. This command will be creating an AFib app as opposed to a UI library or a state library, and the package name is the same value we used to create the Flutter project, Tutorial Eval. The package code is a 3 to 5 character code associated with your project. It will be used to disambiguate a variety of file names and identifiers from those used by other AFib projects. I used eval for this project. And finally, the project style is one of the predefined project styles. The other project styles are documented in the written guide. The local AFib flag references a local copy of AFib and is only necessary because AFib isn't released yet. You will not need to use it yourself. The auto install flag just tells AFib to automatically install required dependencies. Okay, so let's run the AFib bootstrap command. And we will see that AFib has modified and created a bunch of files in the process of converting our standard Flutter project into an AFib-aware Flutter project. Now, let's return to our main function. You may notice that it's changed significantly. Let's again click the debug link. We will bring up the emulator, and we will see a new home screen associated with AFib's app eval demo project style. Our goal in this section is going to be to explain how the Eval app works, so let's start by showing what it does. On the home screen at the bottom, I have a button called I have no objection to hearing it, which cycles through the first few lines of Pride and Prejudice. Note that the first line starts with it is a truth universally acknowledged. The second line starts with must be in want of, and the third line starts with however little known. I will leave it on the third line. The Manage Count button takes us to a subscreen, which allows us to increment a transient count, but it's transient because if I go back to the home screen, then navigate back to the Manage Count screen, it resets to 0. If I increment it again and click Save Transient Count in the history, it will add it to the history list below. If I return home, we will see that the aggregate persistent count now shows the total of the saved counts, which is currently 3. Also note that despite all the back and forth, my Jane Austen quote remains on line 3. It hasn't reverted to the first line. However, now I'll go back into the debugger and restart the app. Now observe that after the restart, the persistent count remains. We will eventually see that it is stored in a SQLite database and is loaded back in when the app restarts. However, my Jane Austen quote reverted to the first line when the app restarted. We can return to the Manage Count screen one more time, increment and save the count again, and we will see that the total persistent history is now 5. And if we return home, the total count is shown on the home screen as well. And if I restart once more, the total persistent count is retained. Finally, let's switch back to the command line in the root of our project. And for the first time, we will use the custom AFib command associated with my project, which is in the bin folder and prefixed with my project code. This command is project specific because it is extensible. You can write your own subcommands, and third-party AFib-aware libraries can also extend it with their own subcommands. It must be executed from the root project folder, so I always explicitly run it this way, starting with dart bin/evalafib.dart. The help command shows the top-level commands that AFib provides out of the box. If I run the test command, I'll see that this project style comes with some unit tests, state tests, and UI tests. So our goal in the remainder of this Understanding AFib section is to explain why this app behaves the way it does and how these tests work. Along the way, we'll get a much deeper understanding of AFib's rendering, state, and navigation models, as well as using prototype mode and AFib's UI and state testing mechanisms. Each AFib UI element, screens, dialogues, drawers, bottom sheets, and widgets, consists of 3 classes working together. A root parameter, which tracks transient information that lives as long as the UI element does, a screen programming interface, or SPI, which exposes data and event handlers used by the UI code to render the UI, and the UI code itself. Let's open up the homepage screen and review each of these elements. The first part is the root parameter. When you navigate to this screen, you supply an initial root parameter value. The root parameter will evolve as the user interacts with the screen. The root parameter knows what screen it is associated with using a unique ID. Note that when you supply a root parameter to a navigation call, this allows AFib to know which screen you are navigating to. When a screen renders, it allows AFib to find the root parameter for your screen and pass it to your rendering function. The root parameter, like all state in AFib, is immutable. All of its member variables are final, meaning they cannot be altered. So anytime we want to change a root parameter, we will need to make a copy of it and alter it slightly. In other words, we will need to revise it. Flutter provides a useful syntax for revising an immutable object, shown here in the copywith function. The parameter syntax says that if we don't specify a line number parameter when we call the function, it will be null. The return syntax says that if the line number parameter is non-null, we will use it. Otherwise, we will continue to use the current value. So, any parameters you pass to copywith will be altered in the revised copy of the object, while any parameters you omit will remain unchanged. This is the essence of revising some parts of an object. AFib generates a copywith function for you, and it also generates simplifying revise methods which call copywith. As your app evolves, you will often find that you need to keep several member variables in sync in some way, and encapsulating that logic in a method with the revise prefix will make it easy for future developers to find the standard ways of revising an object. Next, we have the Screen Programming Interface, or SPI. This object is also immutable and is recreated for you by AFib each time the screen renders. Although this one is quite simple, it still serves the 2 functions that any SPI always does. First, it exposes a simplified view of the state used for rendering the UI. Here, the text of the current stanza of Pride and Prejudice, and the total aggregate count. Note that the current stanza comes from the root parameter, or context.p, while the total count comes from the state view or context.s. The root parameter contains transient data that lives as long as the screen does, while the state view contains data that is shared across screens and is usually loaded from a persistent store or device API. Second, it exposes event handlers that process user actions. Here, the button press handlers for the Manage Count button, which performs a navigation, and the I have no objection to hearing it button, which updates the root parameter. Finally, we have the screen itself. All UI elements in AFib have a build with SPI function, which converts data in your root parameter and state view into a widget that represents your UI. In this case, our screen returns a scaffold widget at its root. The scaffold accepts many parameters for building a material UI, but even if you don't want a material UI, you should still have a scaffold, as it provides all Flutter's basic styling information. If you omit all the scaffold's parameters, you'll just get a blank white screen, but with useful styling information for your child widgets. The body of this screen is provided by the build body method. If I look at that method, it is fairly easy to see that it renders the three main sections on the screen: the welcome widget, the count card, and the Pride and Prejudice card. When working with Flutter, I really like to decompose the UI using sub-procedures. The fact that the SPI has everything I need to do my rendering makes it easy to structure the UI code in this way. I just pass the SPI into each sub-procedure. Flutter is great for prototyping because anytime I save a source file, the UI updates in real time. Here, let's delete the welcome widget. Then, watch the emulator as I hit Command-S to save the source file. You can see the welcome widget disappear immediately. Now, let's go to the build stanzas card method, which builds the Jane Austen section of the home screen. Again, I can edit the UI in real time. Here, I'll modify the title to remove the author name. Again, when I save, the UI updates. If we look at the build stanzas card method, we see how the SPI is used to build the UI. First, it references the text current stanza method to display the current stanza from Pride and Prejudice. And second, it references the onPressed I have no objection method to handle the button click. As you may remember from the trailer, we will later see that we can use the SPI in a state testing context to validate and manipulate the state of our app without building the UI. We will use these two methods on the SPI for that purpose later. Now, let's see how clicking the I have no objection to hearing it button causes the stanza of Pride and Prejudice to update. As you can see, just below Pride and Prejudice, I've placed root parameter in parentheses, indicating that the data that makes this work is stored in the root parameter for this screen. Remember that anytime the state view or root parameter changes, the build with SPI function is executed and the UI updates. Let's start by seeing how the two functions on the SPI that we just discussed display and update the current stanza. First, we will navigate into the SPI's text current stanza method. If we look at the text current stanza method, we will see that it just delegates to a method on the root parameter. If we look in the root parameter method, we will see that it uses the line number member variable to loop over a statically declared set of stanzas using a modulus operator. While we are here, if we look just below that function, we will see the root parameter has a revise next stanza method. It uses the copywidth function that I described earlier to return a new, revised root parameter with the line number incremented by 1. Now, let's go back to the build stanzas card and look at the onPressed I have no objection handler. Here, we see that it uses the revise next stanza method on the root parameter to produce a new root parameter value with the line number increased by 1. It then tells AFib about this updated parameter using the context.updateRootParam method. Let's put a breakpoint there so we can see the update happen. Now, let's return to the build stanzas card function one more time and add a breakpoint right where the current stanza gets rendered. Then we will click the I have no objection button. We will hit our first breakpoint, and if we look in the debugger, we will see that the original root parameter is immutable and as a result still has a line number of 0. But our revised parameter has the updated line number of 1. We are just about to tell AFib about it via the context.updateRootParam method. Remember that when the root param or the state view change, our rendering function should be re-executed. Now we will hit continue, and sure enough, we will break in the rendering function. The rendering function was called because the root parameter changed. If we hover over the SPI's TextCurrentStanza method, we will see that the increased line number in the root parameter has resulted in the rendering function seeing the next stanza, starting must be in want. Note that in the emulator, the UI has not yet updated because we are paused in the rendering function. It still shows the first stanza. Now let's hit continue again, causing the rendering to complete, and observe that the stanza updates in the emulator. So, hopefully it is now clear how the Pride and Prejudice section works. When the user clicks the button, we revise the root parameter by incrementing the line count and then tell AFib about it, causing our rendering function to re-execute and the UI to update with the next stanza displayed. In this section, we are going to understand how navigation works in AFib, see where the initial value of the root parameter for a screen comes from, and understand why, when we leave the counter management screen and return to it, its transient count gets reset to 0. We are also going to begin to see that AFib maintains a single global state which describes the entire state of your app. Although you generally don't need to be aware of this full global state, because AFib hands you the root parameter and state view you need for rendering, we will see near the end of the understanding section that the state is the sole original information source in AFib. Everything else is derived from it. Let's start with the code that renders the home page screen's aggregate persistent count card. Just as in the last example, it uses an accessor on the SPI to show the aggregate click count, and an event handler on the SPI to handle the Manage Count button click. Let's navigate into the event handler. Here we can see that the count management screen has a static navigate push function which returns a navigation action. We pass that action to the context.navigatePush function to execute the navigation. Note that this event handler parallels the previous example a bit. It calls context.navigatePush to tell AFib to perform a navigation, just as the previous example used context.updateRootParam to tell AFib to update the root parameter. In general, the SPI's context member variable and all AFib context variables from runtime contexts provide an API that allows you to manipulate AFib's internal state. Let's inspect the navigate push function on the counter management screen. Here, you can see that it returns a navigate push action and that the action contains an initial value for the count management screen's root parameter. Note that the initial click count contained in the root parameter is passed in as a function parameter. Let's add a breakpoint here. Then, still in the count management screen, let's navigate to the build increment param card function, which builds the card showing the transient counter on the screen. It has functionality very similar to the Pride and Prejudice example. It has a root parameter with a click count exposed via the SPI and an event handler which increments the count by revising the root parameter, also exposed on the SPI. It's the same basic idea we saw on the home page, but it just displays the count rather than converting it into a stanza. Let's add a breakpoint here, right where the count is rendered. Now we will click Manage Count, and when we do, we will see that the initial value of click count is 0 in the initial root parameter value. Let's continue, and we will stop in the code that renders the click count on the counter management screen. This is its first render. But instead of focusing on the SPI, I want to show you that the root parameter value lives in AFib's global public state. If I inspect the SPI, then look for the debug-only public state variable, I can see the entire state of my app. Within the public state is the root state, which tracks all root parameters. Within that is the screen hierarchy, which tracks the hierarchy of active screens. And there I can see that my screen hierarchy currently has two screens, the home page, and below it, the counter management screen. And if I open the counter management screen, I can see that there is an entry for the root parameter. This is, of course, the root parameter I just created in my navigate push function and passed to AFib via the context.navigatePush call. And within it, I can see that the click count is 0. If I click the Increment Transient Count button, I'll break in my rendering function and see that the click count in my root parameter has increased to 1, or, more accurately, that my old root parameter in the root state has been replaced with a new revised version with a higher count. If I continue and then click the button again, I'll see the count increase to 2, and so on. So you may remember that when I hit the back button and navigate back to the home screen, my transient count resets. It may already be obvious to you why, but in case it's not, let's hit the back button. I'm going to quickly add a breakpoint in the home page's rendering function and hit the I do not object button to reach that breakpoint. Now I will navigate back into the root state in my global public state and see that there is only one root parameter in the screen hierarchy, the entry for the home screen. The counter management screen is now gone, and so is its root parameter. This explains why the counter management screen's transient count gets reset to 0 each time we leave the screen. The root parameter that tracks it goes away when the screen goes out of scope. It also explains why the state of the Pride and Prejudice stanza does not get lost when I navigate back and forth to the counter management screen. Its root parameter continues to exist as it is still part of the screen hierarchy. Now let's return to onPressed manage count and change the initial value of the click count to 7. Although this example is arbitrary, in AFib you will often pass information to the navigate push function to control the initial state of a UI you are navigating to. Now let's click manage count one last time. I would now expect the root parameter to have an initial click count of 7, which it does. And if I inspect the root state, it will show a root parameter with a click count of 7, and the UI will render showing 7 from the beginning. If I press increment once more, I will see it go to 8, and so on. Okay, so hopefully we learned that navigation in AFib works by supplying an initial root parameter value as part of the navigate action. Navigation to dialogs, drawers, and bottom sheets works similarly. Even AFib-aware widgets have a root parameter. The written guide explains that there is significantly more flexibility in root parameter handling than I have covered here, some of which we will touch on in the build section. We also learned that AFib tracks the entire state of your app in a single global immutable object, and that object can be viewed via the debug-only public state variable in the SPI. Note that it is called debug-only public state for a reason. You should not reference it in your production code. It is only intended for convenient inspection in the debugger. So we've now understood how root parameters manage screen-specific transient state and enable navigation between screens. But when we click the Save Transient Count and History button, then restart the app, the persistent count and history remains, and the total persistent count is shown on both the home screen and the counter management screen. In this section, we will learn how AFib apps manage persistent state using queries. A query is a class which accesses data in a persistent external store or device API, and then integrates that data into your component state, in this case, eval state. Let's start in the UI code that renders the full persistent history at the bottom of the counter management screen. As you can see, it iterates over a set of count history entries provided by the SPI and calls a function to render each one. That function displays the database ID of the entry on the left and the count on the right. Let's add a breakpoint here so we can review the history when it renders. Next, let's search for the button that saves the transient count, the one in the root parameter, into the history. As expected, that button delegates to an event handler in the SPI. Let's inspect onPressed persistent transient count. And what we see is that it creates a new count history item with the user ID of the current user found in the state view and the click count from the root parameter. It then passes that new item to a write count history item query, which it tells AFib to execute using context.executeQuery. Our goal in this section is to understand what that query does. Also note that here in the UI, the query has an onSuccess handler. This handler is going to get called when the query completes successfully, and in this case, we will use it to reset the transient count to 0. Let's add a breakpoint there so we can see that happen. Now, we will take a look at the query. The first thing to notice is that it has a member variable for the item being written. In AFib, it is common for a query to be configured using member variables. Then, if we scroll down, we can see the substance of the query, which occurs in 2 steps. The first step is the start async function, which is responsible for interacting with some external system to read or update data. It is very often asynchronous, but in this case, it interacts with a SQLite database, which is synchronous. You can see here that it inserts a row in a SQLite table. There are 3 things to notice here. First, note that although the SQLite database is using integer IDs, we convert them to strings. Doing so is not strictly necessary, but it allows you to use human-readable string identifiers for test data, which I strongly recommend. Second, note that the count history item is immutable like all state in AFib, so we must revise it with the newly created database identifier. Finally, note that the revised count history item, which includes that database identifier, is passed to context.onSuccess. The second step is the finish async with response function. This function is responsible for integrating the value passed to context.onSuccess into your AFib state. Here we can see that it accesses the response using context.r, revises the set of count history items at the root of our application state, and then tells AFib to perform the update via context.updateComponentRootState1. There are two additional things to notice here. The first is that when we update our state, it will alter our state view, which will cause all impacted UIs to re-render. Since both the home page and the counter management screen reference the count history, both screens will update. The second is that these two steps are separated so that AFib can skip the first step in testing contexts and provide results directly to the second step. Let's add a breakpoint at onSuccess in the first step, and a breakpoint where we can see the response in the second step. Now, let's increment the transient count twice, each time continuing when the screen re-renders. And then we will click Save, which calls the SPI event handler, which then executes the query, causing us to arrive at the end of our start async function. If we inspect the revised item, we will see that it has a database ID of 4 and a count of 2, which is what is expected if you look at the pre-update UI. Then we will hit Continue and look at the response in the item variable at the top of the finish async with response function. Note that this object is the same value which was just passed to context.onSuccess in the first step. And if we continue a bit further, we will see that our count history has been revised to include the new item, and we will tell AFib to integrate that change into our global component state. I can see it now displays my new item with an ID of 4 and a count of 2. Now we will continue and find that we are back in the SPI code in the onSuccess handler for the query. Note that this closure is actually provided the exact same context that was provided to the query's finish async with response function, and as a result, I can access the response here as well, though in this case, we don't need to. If we step into the onClick clear count function, we will see that it revises the root parameter to reset the transient count to 0, then tells AFib to update the root parameter. If we continue, we will stop in the history rendering function at the very first breakpoint we set. If we inspect the history entries exposed by the SPI, we will see that our fourth entry is now included. The UI in the emulator still only has 3 items because we are stopped in the rendering function. And if we continue one final time, we will see that the UI updates with the transient count reset to 0 and the history and aggregate persistent count updated as expected. You can see a fourth entry with the database ID of 4 and a count of 2. So, hopefully we learned that AFib provides the notion of a query for reading and writing to external data sources, and then integrating the updated state into your AFib state. Each query is broken down into 2 steps, which gives AFib more control over how queries are handled in testing contexts. The results of queries can also be processed in the calling context, in this case the SPI, via the onSuccess handler. We've seen an example of writing persistent state using a query. Now we need to understand how we read persistent state when the app restarts. We will see that this simple app loads all of its state at app startup, but AFib in no way requires you to load state at startup. You can also load state on demand, during or just prior to navigations, or via listener queries which receive push updates on an ongoing basis. We will see some of that in the build section, and the remainder is covered in the written guide. Let's begin by understanding the global component state, which is shared among all the screens, better. This query happens to reference the global state of our Eval app called Eval state. Note 2 things here. First, when we update the global state, we need to specify the type of the state we are updating. That's because third parties can have their own states. For example, the AFib chat support library has a state called AFCS state. So, AFib needs to know which component state we are targeting. Second, when we update the global state, we always update one or more of the root objects just below it. By convention, the class names for these objects end in root. In this particular query, we are updating the count history items root, which tracks all the count history items. Let's open our global state class. When your app starts or restarts, your state will have the value returned by the static function evalState.initial, which in turn is composed of the initial states returned by all your root state classes. Let's look at the initial state for the count history items root class. We'll see that it initially contains an empty map of string IDs to count history items. Yet, if I refresh the app, I see that the aggregate count remains 8, which is clearly not coming from our empty initial state. The goal of this section is to explain how the count history gets populated with the persistent history in our SQLite database. Let's add a breakpoint in the initial state function. Anytime your app starts, AFib executes a query called startup query. Let's open that query and see what it does. We use the startup query to establish a SQLite schema if it does not already exist. That process doesn't really produce a result that we need, so we call context.onSuccess with the AFUnused.unused value. One important gotcha here: even if you don't have any output from your start async function, you still need to call context.onSuccess within it if you want your finish async with response function to get called. Up to this point, we have only seen finish async with response update the state, but it can do many other things. In this case, it executes a query called checkSignInQuery. Let's add a breakpoint here, then open the checkSignIn query to see what it does. Its startAsync method just loads a user credential and passes it to context.onSuccess. In its finishAsync with response method, if the credential is signed in, we then use an AF composite query to execute two additional queries, readUserQuery and readCountHistory query, each of which references the user ID found in the credential we just loaded. This AF composite query will run both of these concurrently and will complete only when they have both completed. We then execute the composite query. In its onSuccess handler, we replace all the existing screens with the home screen using context.navigateReplaceAll. The upshot is that both our signed-in user and our count history will be loaded before we redirect to the home screen. Note that we continue to use the homepage screen.navigatePush static function to create the basic navigation action, but that the return value supports a variety of cast2 methods that allow us to perform other kinds of navigations with it. You can easily get a sense of the different navigations AFib supports by typing context.nav and looking at the type-ahead completions. Let's add a breakpoint on the navigation, then take a look at the readCountHistory query. When we finally get to the query, it is fairly simple. In startAsync, it reads all the count history items from the SQLite database, parses them into a count history items root object, and passes it to context.onSuccess. In finishAsync, it updates the eval state with the new root value. Note that later, when we create state tests that specify responses for our queries from our test data, they will be specifying results consistent with the response type for each query. So, we want to choose a response type that is convenient to construct in our test data. We could have made the response type a list of count history items here if we wanted. Let's add a final breakpoint just as this query is updating our global state. Now, we will refresh the app, kicking off the initialization process from scratch. The first breakpoint we hit is in the count history item root's initial state function. Here, we are creating an empty count history items root. If we hit continue, we will end up in the startup query, which is about to execute the checkSignIn query. I want to linger here for a moment. Just as root parameters were stored in AFib's global public state, our eval state is also stored in AFib's global public state. If we open the context, we will again find a debug-only public state entry. Under components, we will see a set of known component states. Our eval state is there. Third-party AFib libraries can also contribute their own state at this level. If we look at our state, we will see the root objects it contains organized by type name. Currently, it contains users root, user credential root, and count history items root. And if we look at our count history items root, we will see that it contains an empty map. That is what we would expect, as at the time the startup query executes, our state has its initial state, which we saw was empty. If we continue, we will see that the read count history query is finishing. It was executed as part of the composite query. If we look at the response, we will see that it is a count history items root, which contains the 4 count history items currently in our database. We are just about to tell AFib to update the state with that new root object, replacing the root object that contained the initial empty state. We'll continue again, and this time end up in the success handler of our composite query because both the readUser query and the readCountHistory query have finished. Now, let's inspect the success context passed to the onSuccess handler. Here is another AFib gotcha. Because everything is immutable, you always need to reference the context closest to your current execution point. Remember that the original context value, passed to finish async with response, is now stale, as 2 queries have since updated the state as part of the execution of the composite query. The original outer context is immutable, so it reflects the state at an earlier time. We need to use the success context to get the latest state of our app. Okay, if we navigate into the success context again, we can see that our count history items root is now populated with 4 history items. That update happened just after the read count history query completed. Let's continue one more time. And we will see that our home screen has loaded and is displaying the expected persistent count of 8. So, to review, when our app starts or restarts, we start with a fixed initial state which will usually be empty. AFib executes the startup query, which will often execute other queries which load initial data, though they need not load all the data as they do in this simple case. Each query updates the global eval state, and then we are redirected to the home screen. When it renders, its state view contains the full persistent history, and as a result, it shows a total persistent count of 8. Because the state and state view are shared across many screens, and because screens update anytime their state view changes, it is easy for us to share data stored in the state across several screens. In this case, we share it across the home screen and the count management screen. Before we finish, let's return to our eval state class. If we look at its definition, we will see that it has an eval state model access mixin. Let's open that mixin. And here we see how AFib exposes member variables for your various root classes on both your state view and state. It just looks up the root object using its type name. Understanding that both the state and state view are just mappings of type names to object values will help you understand how AFib flexibly manipulates states and state views later. Before we get into the details of state tests, I want to admit that state tests are my favorite part of AFib. When I finished recording and marking up the video for this section, I was so excited to draft this voiceover that I couldn't get to sleep. I love state testing for at least 5 reasons. First, I'm a small software developer, and as a result, I have to write automated tests. I don't have a test staff to run regressions for me. In my experience, writing true UI tests is slow and tedious. You have to refer to widgets by IDs, worry about scrolling, the widgets are a poor format for validating state, and the tests themselves are asynchronous, hard to debug, and slow to execute. State tests address all those issues. They allow me to cover large amounts of business logic quickly. Second, anytime I start storing data on a server or dealing with device APIs, it slows me down. I have to worry about data versioning and what's in my staging environment, or about how the simulator handles a particular specialized API like in-app purchases. State tests allow me to prototype all the way down to the query level without those worries, purely in memory, which is much faster. Third, I invented the notion of the SPI after several years of developing without it. I had to refactor a significant amount of existing UI code in the inciting app, and as I did so, I found that the SPI cleaned up my UI code tremendously by separating business logic out from UI rendering logic. The idea of creating a programming interface that my UI interacts with was a very helpful construct for writing cleaner code. Fourth, state tests in AFib execute synchronously. This comes at a cost. In a well-formed AFib app, the only asynchronous code will be in the start async method of your queries or in pure UI code. But it has the benefit that your state tests are repeatable and easy to debug. And finally, as we will see, the terminal state of state tests can be viewed in prototype mode, and if well designed, can be interactively manipulated just like your real app. As a result, they can be used as consistent, full-featured test environments, which are useful for ongoing development. Given all that, I find that as a developer, I have unique incentives to develop and maintain my state tests that I have not historically had for other forms of automated testing. State tests benefit my overall development process. They are efficient to write, they allow me to prototype complex functionality without messing with staging environments and emulator idiosyncrasies. They help me keep my UI code cleaner, and most important, they establish convenient, interactive environments for ongoing development and debugging. That is why I enjoyed drafting this section so much, and why I dedicate at least 85% of my testing effort to state-based testing in AFib. Okay, so let's get into the details of state tests. Up to this point, we have been working with a debug version of our Eval app. However, I spend the vast majority of my development time in prototype mode. Let's open our eval config file, then switch from debug mode to prototype mode, and refresh the app. As you can see, doing so reveals the prototype mode home page. Although when developing a new app, as we will in the build section, we would typically start by working with UI prototype screens, in this case, we'll start by working with state tests. Every state test automatically appears in prototype mode. It's very important that you understand what clicking on a state test in prototype mode does. It executes the entire state test without ever building any UI, then takes the final resulting state and renders the UI from that. So, when I click on a state test, I should expect to navigate to a UI representing the terminal state of my state test. Here, we can see that when our test ended, we had a persistent count of 10 and that the Pride and Prejudice card was on the second stanza, must be in want of a wife. If I navigate to the Manage Count screen, we will see that I have 3 history entries. The first 2 have IDs Test1 and Test2, while the third has a longer ID. We will see that the first 2 originated in our test data when our app started, while the third was added during the test by clicking the Save Transient Count button. If I click Increment Transient Count a few times, we will see that it works, which isn't a huge surprise since it is stored in the root parameter. But if I click Save Transient Count, we will see that it also works and that it creates another ID similar to the third ID. So I'm going to swipe in the prototype drawer from the right-hand side and click Exit to exit the state test. Let's open the state test we just saw execute and see what it does. Every state test has 3 sections. First, it defines the results of all the queries that the state test will execute. Here, for example, my read count history query will return a result from my test data, while my write count history item query will execute code that simulates the saving of a count history item. Next, it calls execute startup. This is the equivalent of the app starting up and will cause the startup query to be executed. In this app, that query will execute additional queries, and for each one, the start async call will be omitted, and the finish async with response call will be called with the result specified at the beginning of the state test. Now, let's scroll down. The third stage is the execution stage. In this stage, I will repeatedly access the SPI for the active screen, using it to both validate the state the app is rendering from and manipulate the state using the SPI's event handlers. I'm going to explain what this test does line by line, because in order to understand the remainder of this section, you need a decent understanding of what we expect the test to do. The test starts on the home screen. Note that this line doesn't move the test to the home screen. Instead, the state of the app at the end of the startup query process is already displaying the home screen. This line merely asserts that the home screen is showing and sets up a context that allows us to work with it. If we had not been on the home screen, this line would have produced an error. The test then validates that the initial stanza of Pride and Prejudice is displayed, and then clicks the I have no objection button. Note that after we manipulate the state by clicking that button, we rebuild the SPI. I will return to this point later, but remember that the SPI is immutable. Anytime the state changes in the production app, the UI rendering function gets called with a new, rebuilt SPI. We need to simulate that effect in our state tests by rebuilding the SPI each time we change the state. In the next section, we validate that the second stanza is now showing and that the persistent count is 7 using accessors on the SPI. We'll see in a second that it is 7 because the app loaded an initial state with 2 history entries totaling 7. Then it clicks the Manage Count button. In the next section, we are on the Manage Count screen. Again, this line didn't move us to that screen, it just acknowledged that clicking the Manage Count button altered the state to make a new screen active. Here, we validate the initial state of that screen, then click Increment Transient Count 3 times. Let's scroll down to see the rest of the test. Having incremented the transient count 3 times, we validate that the UI is displaying 3 as the transient count. Then we click the Persist Transient Count button. Having done so, we validate that the persistent state is now 10 or 7 plus 3, and then hit the back button, returning us to the home page. Finally, on the home page, we validate that the second stanza is still showing and that the persistent count on the home page is now 10. Remember that when I executed the test at the beginning of this section, the terminal state of the test did indeed show a home screen with a total count of 10 and with the second stanza showing. Okay, so having gone through what the test does, we are now going to set a lot of breakpoints so that we can thoroughly understand what happens when a state test executes. Let's return to the start of the test and open the Read Count History query. We will add a breakpoint in the start async function, but note that the point of this breakpoint is that it will never be visited. In a state test, start async is never executed, and instead the test uses results specified in the test definition. Then, let's add a breakpoint in the finish function. Then we will return to our test. And note that the read count history query will use a response from our test data by specifying a test data ID. Let's find the definition of that test data by searching for its ID. And here we see it. It is a count history items root object, which is a type of result expected by our read count history items query. It contains two entries. Notice that the IDs are consistent with the first two IDs we saw in our history, and the counts are 4 and 3, yielding a total of 7, which is the expected initial persistent count. When the app starts, its read count history query is going to get this value as the response, yielding an initial persistent count of 7. Next, let's return to the test and open the write count history query. Again, we will add a breakpoint in start async, which will never be visited, and one in finish async with response. Then we will return to the test. And add a breakpoint in the code that executes dynamically in place of the start async function when this query executes. This code is basically a replacement for start async used in the state test. If the count history item is new, it allocates a new stable identifier, which is why the third entry in our history has an identifier which looks different. Next, we will add a breakpoint just before we press Manage Count on the home screen, and another just before we press Save Persistent Count. And we will execute the state test again by clicking on it. The startup query executes, which in turn executes the check sign-in query, which in turn executes the read count history query, and that is where we first break. Note that we never hit the start async breakpoint. If I inspect the response to the query, I see that I get the response from the test data, with the two test entries totaling 7. Let's continue, and we will break on pressed manage count. If I inspect the state the UI is rendering from via the SPI, I'll see that the home page is currently showing the second stanza of Pride and Prejudice, which is what I would expect because I pressed the I have no objection button once so far. We will continue and break just before we save the transient count. Note that the transient count the UI is rendering from is 3, which is what we would expect given that we clicked increment 3 times. And note that if I navigate into the SPI's debug only public state, I see that the screen hierarchy has 4 entries. The first 2 are for the prototype mode screens, while the next 2 are for my home screen and the count management screen. And if I view the click count for my count management screen root parameter, it is 3 as I expect. I show you this because it is important to understand that although no actual UI is being built during this test, we are maintaining a model of the UI that we can use later to reconstruct the full UI at the end of the test. Let's continue again, causing the Save Persistent Count button to be pressed. That click will execute the write count history item query. We will break in the dynamic code handler associated with the write count history item query in the state test. If we look at the item being written, we will see that it has a count of 3, which is what we expect. Let's continue. And we will break in the finish async with response function, and we can see that the item we are integrating into our state is the one that we generated in the state test's dynamic handler. We will click continue one more time and complete the test, at which point AFib uses the terminal state of the test to render the full UI of the app. If we click manage count, we can see the 3 entries we expect, the first 2 from our test data and the third generated by the dynamic handler for write count history item query. Note that the state test's query handlers are still active at this point. If I increment the transient count a few times and click Save, I'll break in the write count history item query handler again, this time with an item with a count of 2. And if I continue, I'll break in the finish async function for that query again, integrating my count of 2 and causing the state view to change and the UI to re-render. And if I continue one more time, I'll see a new entry show up with a count of 2 and the ID format generated by my dynamic handler. Now, it may not be quite clear yet how rendering the terminal state works, because this example dumped us onto the home screen. AFib also provides an execute debug stop here call, which stops the test wherever you call it, and then renders that as the terminal state. It's not like the debugger where you can continue after it, but it allows you to easily visualize the UI at any point in your state test. I have added this call when we are on the count management page and after we have incremented the transient count twice, but before we incremented it the third time or clicked save. Let's refresh the app. At the end of this section, I'm going to explain why we need to refresh the app after modifying a state test. And we will navigate down and click on the state test, causing it to execute. And after I skip past all the breakpoints, we will see that I am on the Manage Count screen with my transient count of 2 and only the history items that were loaded from the test data, which is what I would expect if I had stopped the test where I did. I can, of course, increment the count more manually at this point, then press Save, go through the same write query process we have already seen several times, and get the expected result. Now, let's remove the execute debug stop here call and make a different change. Earlier I mentioned that we have to rebuild the SPI every time we modify the state, both because the SPI is immutable and because that is how the actual UI build logic works in a running AFib app. Let's try making our test more concise by consolidating all of our increment transient count calls. The issue here is going to be that the SPI is immutable and contains references to an immutable root parameter. So, when I call onPressed increment transient count the first time, it's going to increment the count from 0 to 1 and update the root parameter. But when I execute it the second time, the click count in the root parameter for our immutable SPI will still be 0. It cannot have changed. So I'm going to increment it from 0 to 1 a second time. And the third call will increment it from 0 to 1 a third time. The upshot is that this test will have a transient count of 1, not 3. So let's refresh the app and execute the test. And we will see that the count of the saved history item is 1, not 3. The point is that you must make sure to regenerate a new SPI every time you call an event handler that modifies the state in some way. Otherwise, you will be working off stale state and get a confusing result. Finally, I'm going to put a breakpoint at the top of the test definition. I'm going to hit refresh and immediately hit my breakpoint. Although I'm not going to discuss it yet, AFib allows one state test to extend another, which allows you to maintain state tests for complex apps much more easily. It does that by running the outer part of this test at startup time in test environments and capturing the test definition in a data structure. For example, all the closures in the execute section are captured in data structures. Then, AFib walks those data structures and executes them when you run the test. When you work in Flutter, you'll be used to code changes being applied immediately, but that isn't true in state test code because your state test code has basically been saved in a global variable. That is why anytime I modify the state test, I need to refresh the app. But note that that is not an issue in any of your app's other code. If I have executed a state test and I'm now in the UI associated with its terminal state, I can modify my UI's rendering function and watch it update in real time when I save the file. That makes state tests very useful as prototyping environments. Okay, we are almost done, but you are perhaps thinking that you cannot run all your tests from the UI, and you're right. Of course, you can also run your tests from the command line. If I switch to the command line and run help test, I can see the different ways I can specify which tests to run. I mostly just run test plain, which runs all the tests, but I can also run a specific subset of tests. In this case, I will just run the state tests, of which I have only one, by running my project's AFib command with test state. I see that it finished with errors. It expected a count of 3 and found 1. That may sound familiar. If I return to the test, I see that I forgot to undo my incorrect SPI manipulation. So let's use undo to return the test to its working state. Then I'll run the test again and see that it passed. Currently, there is a startup time penalty of a few seconds anytime you run an AFib test, but once you pay that penalty, your state tests execute very, very quickly. Even large numbers of complex state tests execute almost instantly, in significantly less than a second. So it is a very scalable form of testing. You might also want to debug your test from the command line rather than debugging it in the emulator. If you do not debug your eval afib.dart command, as that command just modifies a configuration file and then delegates to another process. Instead, you open up the main afib test dart file and debug it. And you'll see that I hit my breakpoints as expected, and that VS Code displays my command line output as expected. Okay, So that was a lot of information, but as I said at the beginning, state tests are my favorite part of AFib. I use them as consistent development environments for prototyping and debugging. I spend more time prototyping in state tests than I do in single-screen UI prototypes. If we look back at the count management screen, we will see that there is a reset history button just below the save transient count button. What I'd like you to do at this point is think through, without writing any code, how you would implement that function in AFib. Where would you add code in the UI file? How would you reset the persistent state? Where would you update your global component state? And finally, what would you need to do to maintain the functionality of your state tests? So, if you'd like to, please pause the video and mentally plan how to implement the reset button while I give you a couple of seconds. Okay, for those who are able to do it, congratulations. And for those who just want to enjoy the show, the plan, starting in the rendering function, would be: first, you'd start by adding a method to your SPI for the onPressed handler of that button. That method would use context.executeQuery to execute a reset query. The startAsync method of that query would delete the existing count entries in the database. Then, the finishAsync method would reset the count history in your state. Finally, you need to go into your state test and add a query response for the reset history query. And that is all that would be required. When you click the button in either your production app or a state test, your query would execute, your state would be updated, your state view would be altered, and both the counter management screen and your home screen would re-render as a result. On the counter management screen, the persistent count would be 0 and the history would disappear. If you return to the home screen, that count would also be updated to 0, since it is derived from the count history in your global component state. Before we continue with code, I want to show you a visual model of AFib that I find helpful. Everything in AFib revolves around the public state, which contains two primary areas: the root state, which tracks transient information associated with specific UI elements in the form of root parameters, and the component state, which tracks information that is synchronized with persistent external stores and device APIs and shared across many screens. For example, in this app, it contains our eval state. When AFib renders a UI element like a screen, it looks up the correct root parameter and required portions of the state in the form of a state view and combines them into an SPI, where they are accessible as context.p and context.s respectively, or context.rootParameter and context.stateView if you prefer. You write accessors on the SPI that combine information from the root parameter and the state view and expose the data in a form that is simple and convenient for your UI code to render from. The SPI is passed to your UI elements build with SPI function, which returns one big widget, which is usually composed of many other child widgets that gets displayed on the screen. A user sees the widgets and decides to interact with them. The user might interact with a widget that invokes an event handler in the SPI, which in turn updates the root state either by updating a root parameter or performing a navigation. If the root state gets modified, the entire rendering cycle begins again, causing the user to see updates appear on the screen. Or the user might interact with a widget that invokes an event handler in the SPI, which in turn executes a query. The query's startAsync method contacts some external data store, maybe Firebase, maybe a REST server, maybe a device API. AFib itself is agnostic on this issue, and then hands the result to the finishAsync with response function, which in turn integrates it into your state. Although it will usually update your component state, it can in theory update your root state as well. Again, this update will kick off the rendering cycle, causing the user to see an update on the screen. In a well-formed AFib app, note that we start with a static initial state, and then everything that changes the state of our app comes from the magenta components here, either the user or one or more external data stores or APIs. When we execute in a state test, it replaces all the magenta components. It replaces the user, and it replaces the external data stores. The execution section of the state test replaces the user. State test code that validates the data in the SPI's accessor methods replaces the user seeing the UI, while state test code that manipulates the SPI's event handlers replaces the user interacting with the UI. Meanwhile, the definition section of the state test replaces the external systems and device APIs that store data. Rather than calling startAsync, the state test provides responses to each query's finishAsync with response function, which are defined in the state test itself. For me, there are two main takeaways here. First, AF public state is the irreducible heart of an AFib app. All functionality in an AFib app is derived from that state, and all changes in an AFib app are caused by changes to that state. In some sense, the state is the only original information in an AFib app. Everything else about the app is a transient phenomena derived from the state. Second, we can use state tests to create a closed system that replaces the two external actors that impact our app. State tests allow us to manipulate the essential original information in our application state without worrying about deriving the transient UI or accessing external data stores and device APIs. That, in one sense, is why state tests are such an efficient way of validating and manipulating your app. They focus on the app's irreducible core essence and eliminate everything that is external to it. In the Building with AFib section, we will see that anytime you generate a new UI element on the command line, AFib automatically generates a UI prototype for it, which you can access in prototype mode. UI prototypes will bookend your software development process. They are useful at the beginning when you are trying to get something on the screen quickly, and they are useful at the end when you want to implement true UI tests on a relatively stable UI. In this section, our goal is to understand how both UI prototypes and the test code attached to them work. In prototype mode, we can navigate into the UI prototypes section. Note that there are tabs at the top for different element types: screens, dialogues, bottom sheets, drawers, and widgets. A UI prototype is nothing more than an AFib UI element hydrated with a specific root parameter and state view. If I navigate into the count management screen prototype, we will see that it displays an initial transient count of 0, which comes from a hydrating root parameter, and an initial aggregate persistent count of 7, which comes from the hydrating state view. In AFib, the file containing UI prototype starts with the same name as the file containing the UI, but with underscore tests added. If I open the prototype file for the counter management screen, I can see the definition of the UI prototype. It has 3 elements: an identifier, a state view, and a root parameter, provided by the same static navigate push function we use elsewhere. Let's start by using the ID of the test. Let's open the prototype.dart configuration file and add this to our list of favorite tests. Then we'll restart the app and see that the test is now on the home screen under favorites, which is more convenient. The entry also shows the prototype's full ID. I can also explicitly reference the full test ID to run the test from the command line. If I switch to the command line and run the test using that identifier, then return to VS Code, then refresh the app again, I'll see that the test now shows up in my recent tests as well. Now, we will return to the prototype definition and understand the other 2 values hydrating the UI prototype, the root parameter and the state view. Let's start with the root parameter, which should be familiar at this point. As you saw earlier, the counter management screen's static navigate push function feeds an initial transient click count into the initial root parameter, which is returned as part of the navigate push action. Let's change the click count to 14, then refresh the app. As in state tests, AFib captures the prototype definition at startup, so when you change the prototype definition itself, you need to refresh the app. Now we will navigate back to the UI prototype via the favorites, and see that the initial click count is no longer 0 but 14, since the root parameter hydrating the prototype now has an initial click count of 14. Now, let's return to the prototype definition and revert that change. Next, we'll understand the state view. The state view is being pulled from our test data using a test ID. If we search for that ID, we'll find the code defining the test data in the testdata.dart file, and see that it is an eval state. Remember that because states and state views are just mappings from type names to root objects, AFib can easily convert from a state to a state view. This state has 3 root objects which were previously defined in our test data. The syntax builds a list of root objects by looking each one up in the existing test data: user's root, a user credential root, and a count history items root, then converting it into an eval state. This is the data that AFib will convert into a state view and use to render our UI prototype. Let's quickly search for the ID associated with the count history items root. We'll find it defined just below our current point. It is the same test data which we specified as the return value from our query in the state test. That is why the data on our screen looks so familiar. AFib's test data is nothing more than a key value store, but because it is widely integrated into all AFib's test types, it is often easy to reuse the test data in many different contexts. You will likely find that you can define just a few full states in your test data and use those states for hydrating many different prototypes. However, you may sometimes want to vary the state view fed to your UI prototype slightly from one of your primary state definitions. Let's return to the prototype and convert the state view parameter into an array of items. AFib will walk the array and integrate each item into our state view. In this case, it will find the state defined in the test data first, which will establish all 3 root items. But then it will find a count history item's root in its initial state with no count history entries. It will add that item to our state view, overwriting the original value with this new object at the root of the state. Note that although I specified a count history item's root object explicitly, I could also have specified another test data ID that mapped to a root object and gotten the same result. If we refresh the app and navigate into our prototype, we will see that it contains a total persistent count of 0 instead of 7 and no history entries. As your application state grows more complex, this ability to easily override small portions of the state to generate additional state view permutations can be useful. Let's revert that change before we continue. Then we will open the counter management screen file. UI prototypes are used at the beginning of the development process to prototype UI elements like this screen in isolation, without worrying about navigation or interactions with external systems. Let's suppose that during prototyping, I decided we shouldn't be able to reset the history here. Let's search for that button and delete it. And when I save, the UI updates immediately. For prototyping purposes, the point of a UI prototype is to feed data into a UI and then prototype your rendering function interactively in real time. I decided I like it there after all, so let's undo and restore the button. In a little while, we are going to see a UI test which refers to specific widgets by IDs. While we are here, note that each of these widgets has a widget ID. These widgets are created using AFib's theme.child methods, which take widget IDs. However, if you are using Flutter widgets directly, then the widget needs a Flutter key, not an AFib widget ID. You can easily convert from a widget into a Flutter key using t.keyForWid, like this, and then refer to the widget ID in the test. By design, UI prototypes focus on only one UI element. You can never navigate away from a UI prototype screen, nor does query execution have any effect. Although I can increment the count as part of the root parameter, when I click the Save Transient Count in History button, nothing happens. As we discussed, UI prototypes also have a second purpose. They are the basis for UI testing in AFib. If I slide the prototype mode drawer in from the right, I can run the smoke test attached to this UI by clicking the Run icon. We will see that it just clicks Increment 3 times, then clicks Save. You can actually watch the UI test execute. Here, you'll see the count increment from 0 to 3. I find watching a UI test execute can be very helpful in test development and debugging. If I swipe the drawer in one more time, I can see the results of the test. Let's return to VS Code and look at the test definition. Because state tests are so useful for testing business logic, UI tests are focused exclusively on validating the UI's content and its interaction with the SPI. If we go line by line, this test verifies that the initial transient count is 0, taps the increment button 3 times, then validates that the transient count is 3. It then taps the Save button and verifies that a write count history item query is generated with a count of 3. You can use a similar syntax to validate root parameter updates and navigation actions. The other thing to note here is that every line begins with a wait. This is critically important. In AFib UI tests, every single line except e.expect must begin with a wait. If you omit the await, your tests will execute in an unpredictable order and you will get confusing and frustrating results. If there is not an await on every line, it's a bug in the test. Let's go back and run all our tests from the command line. You can see that the tests for this particular screen pass. One other thing to note here is that AFib sets the size of the screen used in your test explicitly. You can modify that size in your eval config file. When I first started using Flutter many years ago, I created a test which failed because the screen size Flutter created for the command line test was substantially smaller than the screen size of my emulator, and it took me a surprisingly long time to figure out that they were different. So at this point, you're about 1 hour and 10 minutes into a 3-hour tutorial, and this would be a great place to take a break before we get into building the to-do list. Let's start by understanding what the app we are building will do in its final form. We will build a to-do list app with a Firebase backend. Firebase is a Google service that provides both authentication and a document database with real-time push functionality built in. Note that AFib does not require you to use Firebase, it's just convenient to use in this example. Our app will have a sign-in page sourced from the AFib sign-in open source library and implemented out of the box as part of AFib's App Sign-In Starter Firebase project style. If we sign in, we'll be taken to a home screen that lists our to-do items. Our app will have a menu drawer which allows us to manage account settings, define categories for our to-do items, or sign out. The name and email of the signed-in user appears at the top of the drawer, along with a family code which is used to share to-do items across multiple family members. If we click on Account Settings, we will see that our project style includes the ability to update the user's properties, email, password, or to delete their account. This all works out of the box with our project style. If we click Back and reopen the drawer, we will see that there is a simple screen to define categories for our to-do items. And if I type a new Kids category and tap Add, it will appear in the categories list. Flutter enables my to-do list app to run on iOS, Android, macOS, Windows, and in web browsers. Here it is running in both an iOS and an Android simulator. If I switch to the Android simulator, you can see that I am also able to register new users. My AFib sign-in registration page will be extended using an AFib-aware widget to collect the user's name and family code. Users who share the same family code will share the same to-do list in real time. If I register a new user using the family code JonesFam, which is the same code used by the user on the left, and click Register, we will see that I see the same to-do list in both emulators. If I click the plus button at the bottom, I can add a new to-do item, for example, a reminder to take the kids to tennis, and place it in the Kids category. If I tap Save, I see that the item appears in both lists under the specified Kids category at the top. Although, if I open the drawer in both, you'll see that we are logged in as different users, but with the same family code. If I tap the filter icon in the bottom right-hand corner of the screen, I can use a dialog to choose whether to organize the list by user or category. If I change to user, we will see that the list updates with the new organization, grouping the two items by user rather than category. I'll switch it back to organize by category. Returning to the list, I can also use the edit icon to edit an existing to-do list item. If I add today to the Take Kids to Tennis item and save it, we will see that it updates in real time in both emulators. This real-time update is not limited to the items themselves. If I go into the drawer and choose Account Settings and change my name from Chris to Christopher, when I save, we will see that the name listed on the to-do list items updates immediately in both emulators as well. Finally, if I swipe left on an item, I complete it, causing it to disappear on both devices. We will start by creating a new Flutter project called Tutorial To Do using the Flutter create command, then cd into its project folder. We will also run Flutterfire configure. This connects our Flutter project to a Firebase backend. I also enabled Firebase authentication and Firebase Firestore in my Firebase project and created appropriate security rules for Firebase Firestore. This isn't a Firebase tutorial, so I'm not going to show those details. They are covered in Firebase's own documentation. If I run this project using Flutter Run, we will see that it currently has Flutter's default starter app. While I'm on the subject, one gotcha with Flutter is that VS Code will not report compiler errors clearly in certain obscure cases. For example, if your pod file is out of date, or you reference a Dart package which itself has compiler errors. However, Flutter Run does report these errors. So, if you are having trouble getting your app to start in VS Code, try using Flutter Run from the command line. Next, we will convert our Flutter project to an AFib project using the AFib bootstrap command. As before, I'm running the command directly because AFib isn't released yet, see the written guide for the correct syntax. In this case, I will use todo as my project code, and I will use the app starter sign-in Firebase project style. When I run the command, I will agree to install the dependencies that this project style requires. We will see that it completes with a warning stating that I need to run a second phase using my project-specific AFib command. In this case, the second phase exists because the first phase integrated several AFib-aware packages into our project, and this second phase uses that integration to generate additional code. When I run that second command, we will see that it completed successfully. Next, I will start my app by opening the main.dart file in VS Code and clicking Debug. Note that the first time I run a Flutter project after installing Firebase, it will take a long time to start, but subsequent startups are much faster. When working in Flutter, you will rarely need to restart the app from scratch. We usually just refresh it, which takes less than a second. When the app starts, the standard Flutter starter has been replaced with a sign-in page. This screen is provided by the AFib sign-in package. I don't have any users yet, but if I tap Sign Up, I can register a new one. When I click Sign Up Now, I'll be taken to the home screen, which by default just confirms my registration information and shows the ID of the Firebase authentication record which was created. If I open the drawer, we will see that AFib Sign-In provides a default account settings screen which enables me to change my user's property, actually using the same AFib-aware widget that extended the registration page, as well as change my email, my password, or to delete my account. Our project style implements all of this in Firebase out of the box. If we switch to the Firebase console, we can see that my app created the user under Firebase Auth and a user record under Firestore. If I arrange the screen to see both the Firebase console and the emulator, then edit the user's first name in Firestore, we will see that the homepage updates in real time to display the user's revised name. And I can change it back. I can also sign out via the drawer, and now that I have a user, I can sign in again. This functionality, in addition to a password recovery screen that I did not show, all works out of the box. Our goal is to build our simple to-do list app on top of this existing functionality. In this section, I'll show you how to generate easy-to-maintain client-side state, generate a screen, and switch to prototype mode. AFib makes it easy to generate client-side state and UI from the command line. Because the UI usually depends on the state, you will get more convenient results if you generate the state first and the UI second. In this case, I'll start by generating a to-do item using the command line. If I look at the command, the member variables are just what you would expect, member variables in your new to-do item. In this case, we have just an ID and a title. Note that I strongly recommend using string IDs for your objects, as it allows you to use string test identifiers, which are useful in debugging. In fact, you can specify an integer identifier here, but the generated code will still use a string ID, converting the ID to and from an integer in the serialization logic. Next, we have the resolve variables flag and the add standard root flag. In order to understand these flags, we need to think about how to conveniently maintain immutable data structures. Starting with the resolve variables flag, I have a user that the item is assigned to. I could model my to-do item like this, with my string ID and title, and then an object reference to the assigned to user. But remember that both the to-do item itself and the user object are immutable. They cannot be changed. That means that if the first name of the user changes, then a new revised user object must be created. The only way to integrate that change into to-do items that reference the user is to go through and create new revised versions of each one. That would be tedious. A better solution is for my to-do item to reference only the unique identifier of the user, like this. Then, when I need the user object, I look it up in real time using its ID. In other words, I resolve it when I need it. That way, I always get the latest version. That is what a resolve variable is. It is an object reference which gets resolved using an ID in real time. Which brings us to the second flag, add standard root. That flag defines a standard root object in our global component state which maps string identifiers to our model objects. That standard root has a bunch of useful methods, but among them is the ability to find an object given its ID. This design makes it easy to resolve the latest version of an object when we need it using its ID, and update that object in exactly one place when it changes. If it helps you to use relational terminology, you could think of this as keeping our data highly normalized on the client side, then joining or resolving it only at the last possible instant, typically as we render the UI. Our model objects will typically correspond to rows in a relational table, and our standard root objects will typically correspond to the subset of rows in the table which are currently relevant on this particular client device. A resolve variable is just a foreign key from one table to another. Okay, so returning to this command, those two flags handle all this for us, creating easily maintainable immutable data structures. Let's run the command, and if we open the generated TodoItem.dart file, we will see that it has the expected member variables and an ID variable for the assigned to user. If I scroll down further, I will see that AFib generates a resolve method to look up the assigned to user in the user's root, which maintains a mapping of IDs to users. While we are here, note that AFib generates convenient revise methods, generates your copywith function, and generates two simple serialization methods. Finally, we will see later that all these breadcrumb comments allow you to quickly add additional fields to your to-do item from the command line, rather than maintaining this boilerplate manually. If I open the to-do item root state, we will see that it is just a mapping of string identifiers to to-do items. The parent class has many convenient methods for finding objects and revising them. This set of to-do items is already available on my state and state view through the to-do items member variable. Now let's create a TodoListScreen. Doing so will generate a new screen file containing the root parameter, SPI, and screen classes. I'll use the no back button flag because this will be our home screen and won't have a back button. Okay, so let's run the command, then debug our app in VS Code. And perhaps it's not a surprise to see that nothing has changed. My to-do list screen is not shown on the home page or in the drawer. Now, I could start by implementing some navigation to my screen, and I could manually add some to-do items in Firebase's console, and I could write some queries to read them, and then I could prototype my UI. And if I decided I needed more member variables in my to-do items, I could go and muck around in my prototype data in the Firebase console. But I don't want to do any of that. I want to build a prototype of my to-do list screen immediately without getting sidetracked. And I can do that by opening my to-do config file and switching to prototype mode. Then I just refresh the app using this green circle icon in the debugger. I don't need to rebuild it. If the green circle does not work, try holding the Shift key while clicking it, which does a fuller refresh of your app. If it still doesn't work, be sure that there are not compiler errors in your app or one of the packages it depends on. And having done so, I'll be in prototype mode. And if we navigate into UI prototypes, we will find one for our new screen. If we click on it, we will see the initial screen. If I search for the text shown on this screen, we will find it in our screen file. And if I change the text and save, we will see the screen update in real time. So, to paraphrase Teddy Roosevelt Jr. on D-Day, we'll start the prototype from right here. In this section, we will hydrate this screen with some to-do items from our test data, then build the UI prototype from that test data. Before we do that, as we iteratively change our test data, we are going to need to refresh our app a lot, then navigate back into our prototype in prototype mode. That will get a little tedious. AFib allows me to start the app directly into a specific UI prototype. So let's start by opening our to-do config file, and let's switch the environment to Startup in Screen Prototype. Then let's open the prototype.dart file and specify our to-do list screen prototype as the one to start up in. And if I hit refresh, we will see that from now on, anytime I refresh the app, I'll come right back to the screen I am prototyping. You may remember from the previous section that my UI prototype is defined in a file with the same name as my UI element, suffixed with _tests. And its state view is populated from the test data using a test data ID. Let's copy that and then search for it. We will find it in the testdata.dart file, which defines all of our test data. We will see that it is a to-do state and it is composed of several root objects. Let's find the function that defines the to-do items root object. And just off the screen here, it is currently set to just the initial empty state. Instead, let's replace this with code that adds two simple test to-do items. and we will use the AFib Fixup Identifiers plugin to add in the missing test data IDs. One thing to notice here is that my to-do item refers to a user using its existing test data ID, and that each of my to-do items has a string test data ID. In a production app, these IDs would be the primary key values from your persistent store, but in your prototypes, these are human-readable strings. These users were previously defined as part of the project style itself. String IDs help with debugging in prototypes. When I view a to-do item in the debugger, I will be able to easily see what user it is assigned to just by looking at the text of its assigned to ID. Then we will navigate back to our to-do list screen. And let's start by deleting the code that shows the screen name. One note here is that at the time of this recording, there was a bug requiring me to manually save the ID file modified by the AFib Fixup Identifiers plugin. That bug has since been fixed, but the workaround exists in this recording, so I need to save the ID file manually. Once we do that, our live update starts working again. Then let's return to our screen's build body function and insert some code that renders the first initial version of our list. It's just a sequence of list tiles showing the title of each to-do item and placing them in a list view. Now let's save, and you'll see that our prototype updates in real time. In general, I'm not going to live code in this tutorial because I don't think it has much teaching value and it will slow down our progress. But in this case, I want to show you how I interactively prototype in Flutter. Rather than building an extensive UI in code, I start with the simplest possible UI and then I start iterating on it. So, for example, let's place these list tiles on a card, which makes the list look a little better. Then, let's add a subtitle in a sub-procedure with a placeholder for our assigned to user. Then, let's move the subtitle over to the right using a row. Then let's resolve our user dynamically and display their first name in our subtitle. Here you can see that I am resolving the to-do items assigned to user dynamically in the UI code using the resolve method that AFib defined for me and the set of users found at the root of my state view. Finally, let's go back and add an icon for editing my to-do item. One thing I forgot is that each item in my list should have a unique key in Flutter. It's very similar to React in that way. So let's add a key using a widget ID. And let's use a dismissible widget to add a way to complete our to-do item. And as I was doing that, I realized that I forgot to make the key for my list unique. So I'll use the with1 method on the widget ID to generate a unique ID using the to-do items ID. And I can kind of fiddle around with it until it starts looking right. Maybe I'll add a green background, maybe make my icon white so it shows up. Then realize I need to right align it to get it to show up. Okay, there it is. Then add some padding to make the icon look better. Even if I'm working from a mockup provided by a UI designer, I'd still typically work this way, iterating towards a UI that replicates their design. So the goal here is not to create a beautiful UI, but hopefully you can see how I can use Flutter's live update feature, combined with the ability to hydrate your UI in AFib's prototype mode, to quickly and iteratively prototype your UI. Now, some of this code should really be moved to the SPI, while some of it should really be moved to a theme, but we will get to that shortly. In this section, we will learn how to augment both models and root parameters with additional variables and how to push business logic into the SPI. You might remember that in our final app, our to-do list screen can be organized either by assigned user or category. In this section, we will start to develop that functionality by adding the notion of a category to our items and implementing the organization in the list. We will use this generate state command to generate our category model. It looks very similar to our previous generate command. We will keep our categories very simple with just an ID and a title. Let's run that command, then open our test data and populate a few initial categories. And now we want to add a category to our existing to-do item model. We could do that by hand, but it would be a little tedious, so AFib provides this generate augment command. As you can see here, we specify the name of the item we are augmenting, the same class name we specified for the original generate command, and then we can add member variables and/or resolve variables. In this case, I will add a resolve variable for a category. Let's run the command, and then open the to-do item file. Here we will see that all the boilerplate has been updated to include our new resolve variable. There is a member variable, a revise method, it's part of the copywith method, and it is included in the simple serialization logic. Our existing test data now has errors in it, so let's fix those errors by specifying a category ID for each of our existing to-do items. Our to-do list screen currently shows the user's name and the subtitle of each to-do, but I want to change it so that when the list is organized by user, it shows the category, and when the list is organized by category, it shows the user. To achieve this, I'm going to need the ability to remember how my screen is organized. That is going to be transient data that is relevant as long as the screen exists, and transient data associated with a UI element goes in its root parameter. Let's add a member variable to track how the screen is organized to the root parameter. The root parameter is immutable and as a result has some boilerplate, so let's use the generate_augment command to add our member variable. One thing to note here, I'm going to make the member variable a widget ID because I'm going to use widget IDs for these two cases later and it will involve less redundancy, but you could have used an integer or a bool or an enumeration value if that was clearer to you. Let's run the command, then open the to-do list screen and you will see that it has an OrganizeBy member variable on its root parameter. This change produced some compiler errors in our test code because it is not clear what the initial value of OrganizeBy should be. It is important to note here that sometimes AFib will produce compiler errors after code generation where it doesn't know exactly what you want to do. A compiler error after code generation isn't necessarily a bug. It may just be code that makes more sense for you to complete. Here, I'm going to specify a widget ID representing OrganizeByUser called chip_OrganizeByUser please refactor, and I'll use AFib's VS Code plugin to declare the identifier. If I open the ID file, and search for that name, I can see that the ID declaration is just a string matching the name of the identifier itself. The reason this is a class rather than just a text string is that AFib further disambiguates it with your project code to avoid conflicts with third-party AFib-aware libraries. If I return to my prototype code and use VS Code to refactor all the uses of my identifier, removing the please refactor suffix, then I return to my ID file, I will see that my string value is now out of sync with my identifier name. If I run my AFib Fixup Identifiers plugin, the same one I used to add the identifier in the prototype file, within the ID file itself, it will go through the file and fix any IDs that are out of sync and report what it did. Now, let's return to the screen's rendering logic. Remember, we want to show the user's name when the list is organized by category, and the category when the list is organized by user. This is going to be a form of business logic, so I want to push that logic up into my SPI where it will be easy to test later. First, let's replace this code with an SPI call which will return the text that should be in the subtitle of the to-do item. I'll call it text subtitle. Then let's go up to our SPI and implement that method. As you can see, the OrganizeByUser accessor just references the value in my root parameter to determine how the list is organized. Then, in the text subtitle method, if the list is organized by user, we will resolve the category of the to-do item and return its name. If the list is organized by category, we will resolve the user and return its first name. Remember that in my prototype, I initially specified chip_OrganizeByUser, so I would expect the subtitle to show the category. Let's refresh, and we'll see that the category now shows up in the subtitle. Then let's go back to the prototype and change the root parameter so that the screen is initially organized by category. Then let's refresh the prototype, and we will see that the subtitle is showing the user, which is what we would expect when the list is organized by category. Then we will return to organizing the list by user. The other thing we need to do is actually organize the list items into sections by either user or category. Let's go to our main rendering function and note that the code currently reaches down into the SPI's context member variable to access the to-do items directly. Generally, reaching down into the SPI.context directly from the UI code is not a good idea. Instead, we want to let the SPI encapsulate data access and filtering. So we will replace that code with code that accesses the set of sections in the list and then displays a widget labeling each section, and then a second method that returns the set of to-do items in a specific section. And then we will render those to-do items. Again, this grouping and filtering logic is business logic, so we want to push it into the SPI. Let's navigate up to our SPI and insert those two methods. If we look at the methods, there are a few things to note. First, in the section's accessor, I introduced an abstract superclass called IDTitleItem that just says that both users and categories have a title and an ID. So that allows me to return either categories or users directly from my section's accessor. Second, I've introduced an accessor called pendingItems, which currently just returns all the to-do items from the root of the state view. Third, depending on how the list is organized, I resolve each to-do item's section or category, and then build a map to get the unique set of users or sections. Fourth, I sort the resulting list of users or sections alphabetically just to keep the order stable. Finally, in the items for section method, I am just deciding which to-do items to display depending on how the section is organized, and sorting those by title to keep the order stable. Now, when all this compiles, we will see our UI update to show the list organized by user, with a category shown in the subtitle of each item. And if we change the prototype definition back to chip organized by category and refresh, we will see that the list is organized by category with the user's name in the subtitle of each item. Next, we are going to create a dialog box to let the user choose how to organize the list. In this section, we will learn how generate commands map to file locations, about global root parameters, using type-ahead with AFib themes, and returning results from dialogs. Let's start by running a command to generate the dialog. Here, we are going to add a widget ID to the root parameter to track the OrganizeBy setting using the member variables flag. I'd like to note something about the way AFib's generate commands map to files. See here how the parameter after generate is UI, and the class name ends in dialog? Let's run the command and look at the output path for the resulting file. It is stored in lib UI dialogs. We can see that the first folder came from the parameter after generate, and the second folder came from the suffix on the class name. That suffix also determines what kind of UI is being generated. This pattern is replicated in all AFib generate commands. You can predict where the generated file will be stored based on the form of the command itself. We are going to focus on this dialog for a while, so let's open up the prototype.dart file and change the prototype we are starting up into our dialog prototype. And I'm going to try to refresh the prototype, and it's not going to update. If your Flutter code is refusing to update, it is often because you have a compilation error in the code that you haven't noticed. That is the case here, so let's fix the compilation error. We will set our dialog to start with chip organized by category selected. Now let's refresh the app, and we will see the prototype for our dialog. I'm going to go ahead and update the UI code off screen. While I do, there are 4 things about dialogs and their root parameters that I want to explain here. First, bottom sheets are extremely similar to dialogs in AFib. I thought about including one in this tutorial, but doing so didn't teach much beyond the existing dialog example. Second, it's important to know that root parameters for dialogs, bottom sheets, and drawers are not tracked in the screen hierarchy. There are a variety of cases, drawers that are being dragged onto the screen dynamically, bottom sheets that persist across multiple screens, where that does not make sense. Instead, the root state in AFib has a global pool area, which contains root parameters that are global and exist forever unless you remove them. Root parameters for dialogs, bottom sheets, and drawers automatically go into the global pool. Third, anywhere you can specify a root parameter, you can specify an AF root param ref, which is just a reference to an existing root parameter. It will often refer to a parameter in the global pool, but it can also refer to one in the screen hierarchy. So, for example, suppose you have a bottom sheet and you want its root param state to be preserved across screen transitions. You would establish an initial state for the root parameter by writing it to the global pool, maybe at startup, and then when you open the bottom sheet, you would refer to that existing global root parameter by specifying an AF root param ref as the root parameter. Finally, note that your global component state and the state view derived from it and your global root parameters have the same lifespan as long as the application is running. Most often, your global component state will contain information that is synchronized with some external store or device API, while your global root parameters will contain transient UI state. However, you can theoretically store UI state in a persistent store and then synchronize it with a global root parameter if that feels more natural in a particular situation. You would just read and write the global root parameter using the finish async with response method in a query. Okay, so now that I've finished throwing together a UI, let's look at a few relevant aspects of the code. First, I have created a subprocedure to build my choice chips for selecting a user or category in the dialog. If I look at that sub-procedure, we will see that it creates the choice chip shown in the dialog, and that both determining whether the chip has been selected and selecting a chip have been pushed into my SPI. This captures the two essential operations that SPIs encapsulate: accessing data used to render the UI, and event handlers used to handle user interactions with the UI. If I look at the SPI code, we will see both that the isSelected accessor just tests against a value from my root parameter, which is coming from this OrganizeByAccessor, and that my event handler just revises and updates the root parameter by calling onChangedOrganizeBy. Note that our SPI also has an onPressedClose handler. It calls onCloseDialog, and that we pass the current root parameter of this dialog to that function. Note that you could also write this way, using context.closeDialog. As a general rule, I like the idea that your SPI event handlers use methods on the context to manipulate AFib's state. That is actually exactly what onCloseDialog does. It's just a shortcut that handles passing the screen ID for you. Now, let's return to the rendering method because I want to briefly introduce AFib's theming mechanism. The functional theme is always available on the SPI. It's called a functional theme because it is used not just to access attributes like, say, a color, but also to access simple reusable UI functions like, say, creating a margin around something, or an icon, or a particular style of button. All theme methods use the type-ahead convention that the function name starts with the same text as the named parameter it is filling in. So, for example, if I need to fill in a margin parameter, I start by typing t.margin. Similarly, if I want to fill in a border radius parameter, I start by typing t.borderRadius. Note that most Flutter widgets have either child or children parameters. So, AFib provides lots of t.child variants for creating simple widgets. There are a number of advantages to using the t.child variant, including a simple internationalization mechanism, automatic translation of AFib widget IDs to Flutter keys, and the ability to globally restyle widgets returned by the t.child functions later. For now, it's useful for you to know that as you prototype, the theme provides a lot of type-ahead methods that allow you to defer global UI decisions, like what color to use, until later. You can also add your own methods to the theme. We will actually end up centralizing some of the chip-related logic in our theme a little later, when we discover that it is reusable. So we need a bottom bar on our to-do list to allow us to open up the OrganizeByDialog. In this section, we will add that bottom navigation bar, learn about a gotcha opening a drawer, add a filter icon to the bottom bar, and connect it to the OrganizeByDialog. We already have the prototype.dart file open. Let's switch to start up in our to-do list prototype again. Then we will refresh. The original homepage that came with our bottom sheet had a bottom bar which opened the drawer. That bar was an AFib-aware widget called Signed In Bottom Navbar Widget. Let's open the to-do list screen and start by adding that bottom bar widget to our to-do list screen. The scaffold that sits at the root of our screen has a parameter for specifying a bottom bar called Bottom Navigation Bar. Let's put it there. And because it's an AFib-aware widget, it needs to have a root parameter. This widget's root parameter doesn't have any interesting data, but it's useful as an example later, so let's pretend that it did. There are a variety of ways to specify a root parameter for a widget, but in this case, we will specify it directly using the launchParam parameter. And when I save the file, we will see the bottom navigation bar appear. And we will see that the drawer icon it contains doesn't work. This is a bit of a Flutter gotcha. You must specify the drawer as part of your scaffold, and if you don't, the call that opens the drawer fails silently. So let's add the drawer which was defined as part of our project style to the scaffold, and save. And now the button works. Okay, the other thing I want to do is add an icon on the right-hand side, and I want it to open my OrganizeByDialog. It seems to me like I might not always want to have an OrganizeBy icon on the right-hand side of my bottom bar. So let's open the bottom bar widget file and add an optional child widget for the right-hand side of the bottom bar. Note that I am adding the widget to the UI element itself, not the root parameter. The root parameter is part of the state and should not have widget references. The written guide has a clear set of guidelines for what values should be passed as widget constructor parameters and what values should be passed as part of the root parameter. And in the rendering function, we will go down, and if the widget is specified, we will add it, and we will place space between the menu widget and the right side widget. While we are here, so we don't have to return, Flutter lets us specify a cutout shape for the bottom bar, which will eventually contain our center button. Let's add that now. Then I'll return to the to-do list screen and add an icon button to the right side of the bottom bar. And I'll add an event handler to the SPI. The event handler shows the OrganizeByDialog using the context.showDialogAfib call. Just as with a screen, we launch the dialog using its navigatePush method. And the showDialog method also takes an onReturn handler, which receives whatever was passed to the dialog's onCloseDialog method. In this case, we pass the dialog's root parameter to the onCloseDialog method, so that is what I will get in the onReturn handler. I can use the OrganizeBy value from the dialog's root parameter to revise the TodoListScreen's root parameter, which I then update. So, to be clear, the dialog is initialized with the TodoListScreen's current OrganizeBy setting here, and then integrates the OrganizeBy setting returned by the dialog here. So, now when I tap the filter icon, the dialog appears with the current setting, and when I change it and tap Close, the TodoListScreen's root parameter changes, causing the screen to re-render with the specified organization. And I can open it again and switch it back. Before we finish this section, I want to go back down to my icon button. So I'm not really happy with this icon, and when prototyping, this is the kind of thing that can send me down a rabbit hole. All of a sudden, I'm integrating FontAwesome icons and obsessing over which icon I should use. Furthermore, in a real app, it's plausible that I might end up using this icon in several places. This is exactly the kind of situation where I would like to just throw the icon into my theme. It lets me move on, knowing that when I get around to having a better icon, I can update it in one place. So let's do that. First, we will add a call to a new method on the theme. Remember, we want to preserve the type-ahead conventions used in themes. So because this will typically fill in a parameter named icon, we start the method with icon. Doing so will make it easy for me to rediscover this icon later using type-ahead. Then we will open up the theme file and add the implementation. One nice thing about Dart is that if I discover I need to be able to modify the color or size of this icon later, I can add an optional named parameter to this theme method without breaking any of the code that expects the method to have no parameters. And now, my to-do list prototype can be organized by either user or category using the icon and the dialog. You may remember that there is a screen in our app that allows us to define categories. In this section, we are going to build that screen. You might think that there is nothing new to learn from building this screen, that we already more or less know how to do it, and you'd almost be right. Were it not for the fact that for this entire tutorial, I have been burdened with a shameful secret which I have been hiding from you, and which now I have to confess. Some of Flutter's native widgets have state. The idea that a widget would have its own independent state is really outside of AFib's model, in which all the state is in the global public state, and the UI is just a transient phenomena derived from that state. As a practical matter, this isn't a developer productivity problem, nor is it likely to introduce production bugs, but it is a bit tedious. So now we are going to deal with it. We will start by generating a new DefineCategoriesScreen using this command. Our screen will have a single root parameter variable called categoryText, which will track the name of the category we are about to add. Now, the good news about stateful Flutter widgets is that the Flutter widget state needs to live as long as the screen does, and we already have something that lives as long as the screen does, the root parameter. So, the Flutter widget state can reside in our root parameter. Our command will also take this flag, withFlutterState. This flag derives our root parameter from a special superclass which provides some utilities to our root parameter to manage Flutter widgets that contain state. Let's run that command, and note that the new prototype already references our default test state view, which already contains categories at this point, so I don't need to add any additional categories. I'll go into prototype.dart and make this new prototype the active one, and I'll cut away while I prototype the screen. When I'm done, you can see that we have a Define Categories screen showing the two existing categories from my test data with a way to enter and add a category at the bottom. Let's look at how the text editing field at the bottom of the screen works. We'll open the DefineCategoriesScreen file. Note that AFib generated a root parameter derived from a with_Flutter_state superclass, and that it now takes a constructor parameter with the type AF_Flutter_root_param_state. That class is a utility for tracking our Flutter widget state. When I create a new root parameter, I need to provide an initial AF_Flutter_root_param_state object. Let's see how that parameter gets populated in the root parameters create method. You can see that I create an AF text editing controllers object. This is a wrapper around Flutter's text controller widget state. If I scroll over, you'll see it's initialized with the value of category text, and it is associated with a specific widget ID. That text controller's wrapper is passed into the Flutter state, which in turn becomes part of the initial root parameter. The Flutter state can also contain other Flutter widget states like scrolling controllers, tap recognizers, focus controllers, and so on. But in this case, it needs to contain a text editing controller for my widget ID. AFib provides a utility class for creating and managing these controllers, which associates a specific controller with a widget ID. Then, that is passed into the Flutter state, which becomes part of the root parameter. Note that the initial state of category text is passed in during the creation of the controller. We need to keep our AFib state and the state in the text controller in sync. Now, let's look at the rendering function. And we will see that AFib's theme provides a child text field method. This method takes 4 important parameters. First, it takes the root parameter itself. AFib uses this to access the text editing controller via the Flutter state. Second, it takes the widget ID. This widget ID needs to match the widget ID we specified when creating the text editing controller. Third, it takes an expected text value. The expected text comes from our AFib state. In this case, the category text in our root parameter. The expected text is optional, but it will catch bugs that would otherwise be confusing if your AFib state gets out of sync with the Flutter widget state. Of course, they couldn't get out of state if the Flutter widget did not have any state, but it does, so we have to deal with that. And finally, it has an onChanged handler, which is mapped to an event handler. Let's open that event handler. And here we find the final indignity. In this SBI method, we must call context.updateTextField with the widget ID and the updated value. This is necessary only in one case, when a state test executes without building the UI, and then AFib renders the terminal state of the state test in the UI in prototype mode. Then, when the UI does get built, the AFib state will have the correct value in the category text member variable of the root parameter, but the value in the Flutter widget state will be empty. And in that case, if you passed in the expected text parameter to the child text field method, you will get an assertion failure saying the two values are out of sync. All right, so to handle text fields, you need to do 4 things. You need to use the with_Flutter_state flag when you generate the UI item. You need to declare a text controller as part of the Flutter state in your root parameter. You need to pass it to your child text field call when you're rendering your UI. And you need to call context.updateTextField in your event handler. I tried repeatedly to find ways to reduce this complexity, but I was not successful, which made me feel very sad and frustrated. There are a few more things we can learn from this screen. First, if we click the Add button in the screen prototype, there's nothing obvious for us to do. Ultimately, we are going to have to update our Firestore database and then integrate the result into our state, but it's too early for that at this stage of the prototype. So, for now, the Add button isn't going to work. The only thing I can do is add a logging statement in the event handler, just so that I can see that something is happening. AFib has a log member variable built into every context. Here, I'll log that the button was clicked. If I open my config file, you can see that there is an entry for the types of logging that are enabled. Also note that there is this comment syntax in the list, which lets you easily enable and disable logging categories without deleting them from the file. Now, if I add some categories, you'll see a log message in the debug console. Second, I might like to implement an error message if the user adds a duplicate category. This is a chance to note that AFib provides shortcuts for displaying simple info, warning, error, and choice dialogues. Here, I'll display an error message. You can modify the appearance of this dialog by overriding one of AFib's core themes, but that typically wouldn't be useful during the prototyping phase. Now, if I attempt to add a duplicate category, I see an error message. If I switch back to the TodoListScreen prototype in the prototype.dart file, then refresh and open our drawer in the prototype, then let's open the drawer's UI file and add a menu option for navigating to our DefineCategoriesScreen. As you might expect at this point, we add an event handler in our SPI, and it uses context.navigatePush and the screen's static navigatePush method to do the navigation. And when I save, we see that the drawer updates with a new menu item. However, if I select it, no navigation occurs. This is expected. In AFib, UI prototypes are always fixed on a single UI element. You cannot navigate away from them. This is the final new screen we need to prototype, and we'll use it to touch on guidelines for editing persistent data, how to supply test data to a root parameter in a UI prototype, how to use an SPI to simplify UI code, and how to promote UI utilities into your theme. Let's start by using this command to generate the screen. Note that in this case, I made the to-do item that we will edit a member variable. Although there are many ways you could model data in AFib, if you are saving data in real time after any change, you would be most likely to use a resolve variable. While if you are using an explicit save action, you would be most likely to use a member variable that you can repeatedly revise outside your global component state. In this case, our root parameter has an explicit reference to the to-do item we are editing because we will have an explicit save button. So let's run the command, and we'll have a compiler error in the prototype because AFib doesn't know how to specify an item to edit as part of the root parameter. Let's start by opening up our test data, and note that we are already defining a test data ID for the todo by milk to-do item. Then let's switch back to the prototype definition. In addition to referring to test data for the state view, I can also use context.find to look up test data for use in the root parameter. Let's do that to find the by milk to do and pass it as the item to edit parameter. Then we will quickly open the prototype.dart file and specify this new prototype as the one we want to start up into. Then let's refresh the app since we changed the test data, and we will start up into our EditTodoItemScreen, and I'll go ahead and prototype the UI off screen. When I'm finished, we will see that the UI has a text edit where I can search for a specific category. If I search home, it just shows the home category chip below. Looking at the code, the ability to search for a category by name is a good example of how the SPI is useful in a testing context. If I look at the rendering function for the list of available categories, I see that the SPI has an onChangeCategorySearch method, which updates the search text in our root parameter. And a little farther down, I see that the SPI returns the set of categories to render. Each one is rendered as a chip. If I look at that function, I can see that it just filters the set of categories to render using the search text in the root parameter. Later, when we implement a state test, these two SPI methods will constitute a very convenient way to validate that this search mechanism works properly. I can repeatedly change the search text using the event handler and then validate that the correct set of categories are returned. My UI logic, meanwhile, gets to be much simpler. It just renders the categories it is told to as chips. If I later change the search algorithm, perhaps doing more fuzzy matching, the UI code itself is unaffected. Second, this root parameter's revise methods provide a simple example of how encapsulating the copywith method in a revise call is useful. My root parameter has an isChanged member variable, which tracks whether the to-do item has been edited and only shows the save button if it has. I'm going to change the method that revises the item to edit to set isChanged to true anytime the item itself gets revised. If another developer adds more information to the to-do item later and uses typeahead to discover the revise item to edit method, then they will pick up the isChanged logic without knowing that it's there. If I had just had copy with calls scattered around, the developer might not have realized that isChange needed to be updated as well. And finally, with this TodoItemScreen, we don't currently have a good way to implement saving the item. So we have a log message when we save the item and leave it at that. Now let's return to our to-do list and add the ability to navigate to this screen in two places. First, we will add the ability to visit it when the user clicks the edit icon on an existing to-do item. We will add an SPI event handler and then do the navigation within it. Note that an existing item starts out unchanged, so its root parameter starts with its isChanged flag set to false. Also note that because my to-do item is immutable, I can pass the item from my state into a context where it will be edited without worrying that the item in my state actually will be modified. In an architecture that did not use immutable data structures, you would often have to make a copy of the to-do item here to be sure that changes to it didn't accidentally get propagated outside the editing context. And second, Flutter supports the notion of an action button in the scaffold. Let's add an action button and map it to an SPI event handler. And in that SPI event handler, we will create a new to-do item and navigate to it. This item starts out changed, so we will set the isChanged flag to true. And with that, we are done prototyping new screens for our to-do list. If we open To-Do Config and go back to standard prototype mode, then refresh, then navigate into the UI prototypes area, we will see that we now have 3 prototype screens: the to-do list screen we just saw, the Define Categories screen, and the Edit To-Do Item screen. We also have the dialog for choosing how to organize the list, and we have the menu drawer. You might show these screens to an internal stakeholder and get feedback on them before developing a wireframe that you could show to customers. There is one more thing I want to prototype, however. In our To-Do app, each user is going to have a family code, and different users that share the same family code will share the same to-do list, with changes propagating across users in real time. In a real app, the family would probably be an object in the system, and there would be some invitation mechanism, but we want to keep this simple, so we will just collect a family code during registration and query all our to-do related data on that family code. The registration page is part of the AFib sign-in library. Very briefly, I want to stop and show you the AFib sign-in project itself. If I started in the debugger, we will see that an AFib-aware UI library is just an AFib Flutter project that is always in prototype mode. When I developed AFib Sign-In, I developed it entirely in prototype mode with the expectation that the screens would be used in other apps. If I look at the UI prototype screen, I see that there are prototypes for all the screens AFib Sign-In provides. If I navigate into the Sign Up screen, note that there are no text edits for the first or last name or a family code. If we shut down the AFib Sign-In project and return to our original To-Do tutorial project and start it in prototype mode, we can navigate into the libraries area and see all the AFib-aware libraries that have been integrated into Tutorial To-Do. If I navigate into the section for AFib Sign-In, I see all the prototypes that it defines. These are the same prototypes I used to develop AFib Sign-In in isolation. Let's select the Sign Up Pages prototype. As I've mentioned in the past, the top controls come from AFib Sign-In itself, while the bottom controls come from an AFib-aware widget that is specific to our To-Do List app and was created as part of our project style. As you can see, our app has modified AFib Sign-In's default UI. In the remainder of this section, we will understand how that custom UI works and change it so that it collects a family code rather than a zip code. Let's start by talking about how you integrate a third-party library into an AFib app. If I switch to the command line, I need to run an integrate command that looks like this. I need to specify the package name and the package code. Note that I'm not choosing these values. They are intrinsic to the library. If I don't specify them correctly, I will get compiler errors. I would normally run that command to integrate the library, and it will give me the option to install the package in my pubspec.yaml and then do the integration. But in this case, the project style already did that for us. This command just adds registration hooks for the library in several files under initialization install. If I search for AFSI install, we will see that my AFib sign-in library has 3 integration points. AFSI install base, which can install custom configuration values in our todo config file, AFSI install command, which can install custom commands under our todo AFib command, and AFSI install core, which can install a wide range of UI, state, and query hooks in our runtime app, most of which are defined in our todo DefineCore.dart file. The integrate command just adds these function calls. Now that we know how a third-party library integrates with our app, let's figure out how our app's custom widget ends up on this AFib sign-in screen. AFib sign-in has its own theme called AFSI default theme, just as our app has a todo default theme. We can override that theme, providing our own subclass implementation. If it helps, you can think of AFib as supporting an extremely limited form of dependency injection between the library and our app. If I switch to the command line, I can use a command to create a theme override which looks like this. I just specify a theme name of my choosing and specify which theme I am overriding. But actually, our project style already did this override for us. Using the form of the command, I can guess that it will be in the override subfolder under themes. And if I look in VS Code, I find it there and open it. And here we can see that it overrides a method called childExtraInputsRegister, which returns an optional widget. In this case, we are returning our app-specific registration details widget. Now, in this case, the theme contains a method which was meant to be overridden, but open source AFib UI libraries are also strongly encouraged to use the theme's standard child methods whenever possible. Doing so allows you not only to restyle standard widgets, but because all those methods return generic widgets, you can often insert additional UI onto an existing screen in ways that the library author did not anticipate. For example, you might override the standard childPrimaryButton method, check for a specific widget ID, and return a column containing not just the primary button, but some additional controls above or below it, or a row containing controls to its left or right. For example, perhaps you would want to add a link for a privacy policy, which AFib sign-in currently doesn't explicitly support. Okay, we are going to focus on this screen for a while, so let's open the todo config file and switch back to the mode where we start directly into a UI prototype. Then let's go to prototype.dart, and rather than starting into one of our own prototypes, let's start into the AFib sign-in sign-up prototype. We can find it using AFib sign-in's AFSI prototype ID class and type ahead. And if we hit refresh, we'll see that it takes us directly to the sign-up screen prototype. Now, let's go to the command line and augment the registration details widget to include a field for our family code. Here, rather than having my command work, it fails with errors. This was not planned, but it's useful to explain. If I look at the error message, it's explaining that I am importing Flutter UI into my command line app, which isn't allowed. After studying this message, it becomes clear that my prototype.dart file is including AFSI flutter.dart, which references all of AFib's sign-in's UI. Let's open that file, and we will see that when I added the AFSI prototype ID reference, I accidentally included all of AFSI Flutter instead of just its IDs, which was unnecessary. So let's fix that. Now we can return to the command line, run the augment command again, and it will work. Then let's return to the screen and change the UI so that it displays the family code rather than the zip code. To keep this simple, we will just orphan the zip code rather than deleting it. This control uses the new Edit Family Code widget ID, which I will add. And here is where that shameful secret comes in. We actually need to make several changes to make our new text field work. We need to add context.updateText field for the new widget ID into the change handler for our new widget, and need to add a text controller into our root parameter creation, and we need the user itself to have a family code. We will switch to the command line and augment it. And while we are at it, let's augment the category and the to-do items themselves to have family codes as well. Okay, and after I fix some test data definitions and navigate push calls which now require the family code, which I will do in a time lapse, We need to refresh the app because we changed the content of the root parameter to include the new text controller. And we will see that our registration now accepts the family code, but it shows the widget ID itself as the label. AFib actually has a simple internationalization mechanism which was designed to allow custom translations for third-party UIs like AFib sign-in. If I open the TodoDefine core file and associate an English translation with the widget ID of the text field, then refresh, the label for the family code will display. And now I can edit the family code. But suppose I also wanted to edit the text for the Sign Up Now button. I can open the theme panel of the prototype drawer and as my language, choose identifiers. When I do so, you'll see that AFib shows all the identifiers used to specify text in this UI. The written AFib guide describes several ways that translations can be specified. In this case, AFSI is using a widget ID for the register button. If I associate a different translation with that widget ID in my define core file and refresh, we will see that the translation for the button changes from Sign Up Now to Register. I'll just briefly mention here that all the theme.child methods which can display text take an object as the text rather than a string. That text parameter can accept 5 different kinds of values. They can take an AF translation ID, a string in your default language, an AF not translated value for values that are not translated, an AF translation template value for cases where different languages insert values into an overall template in differing orders, or they can just use the widget ID as a translation ID if no text is explicitly specified. The written guide covers all this in detail. But that raises a second question, which is, how does AFib Signup know what to do when I actually click Sign Up? The answer to that question involves another form of override for a concept we haven't encountered yet, the Library Programming Interface, or LPI. An LPI is a structured way for libraries and apps to communicate with each other. LPIs can be accessed easily from any AFib runtime context. They can be used for 2 purposes. First, they can be used to provide an approved interface which allows an app to manipulate the internal state of a third-party library. AFib Sign-In doesn't have a global component state, but it does have some specialized root parameter states. If we open the check sign-in listener query and look at finish async with response, we can see that it accesses the AFSI manipulate state LPI and then uses it to update the status of the sign-in page, which starts as loading, but here transitions to a ready state, which presents the sign-in controls. Second, an app can override an LPI, just like we did for the theme, and provide its own implementation for the LPI's methods. In this case, AFib Signup provides a sign-in actions LPI, which has methods for sign-in, sign-up, reset password, change email, and delete account. My app provides overrides for each of those methods. If we return to the command line, I can show you the necessary command to override the LPI. However, again, our project style already overrode the LPI in this case. So I can use the form of the command to predict where the LPI file will be. And sure enough, I can find my LPI under Override LPIs. Let's focus on the onSignup method. It receives only an email and password, which are the 2 things AFib Sign-In itself collects. But I want to include the user's first name, last name, and family code in the registration process. Note that I could have just used this call to navigate to 1 or more additional registration pages of my own design. But we are using this example to show how you can extend existing third-party UIs in AFib. As you saw above, our registration details widget captures that information in its own root parameter. We can access that root parameter, which is located using both the ID of the screen it resides on and the widget ID. And then we can combine the details from the widget's root parameter with the email and password and use those to handle the registration via a registration query. I don't actually need to change anything about this code to make it work with the new family code. The registration process already saves the user created by the registration details widget, and AFib already added the family code to the serialization logic. So, as things stand, registration will now create a user with the specified family code when a user registers. In this section, we learned that AFib supports heavyweight third-party UI libraries. We can modify the UI those libraries provide by overriding their themes. We can extend those UIs in complex ways using AFib-aware widgets, which maintain their own root parameters. And finally, we can modify the way those libraries behave by overriding or manipulating their library programming interfaces, or LPIs. So you are now 2 hours and 15 minutes into a 3-hour tutorial. If you're still going, this would be a good place to take a break before we get into building a wireframe and converting our app to work in production in the next few sections. So, we have been able to create a UI which is pretty close to our final UI, but each screen currently exists in isolation. Next, we are going to create a wireframe demo for our app. A wireframe is just a way to tie several prototype screens together and show data moving between the screens so that the app appears to work. You might use a wireframe to walk a potential customer through a structured demo, or to produce a pitch video for a prototype version of your app. In this section, we will learn how to create a wireframe and how to use wireframe events to simulate persistent data and navigation. So, let's start with the command to generate a wireframe. Wireframes exist under the test folder, and so we use generate test. We also need to specify the initial screen for the wireframe. If we open the file that was created, we will see that the wireframe definition is very similar to a UI prototype definition. It starts with a state view, which is pulled from the test data, and a root parameter for a specific screen, which is created using navigate push. In this case, our initial screen is the to-do list screen. The main difference is that it has a wireframe body function. We will come back to that function in a minute. In the meantime, we need to fix the compiler error here and specify how the to-do list screen is initially organized. Let's switch to the to-do config file and change back to our normal prototype mode, and select the wireframes area, and select our demo wireframe. And we will see that it dumps us into the to-do list screen with the initial state pulled from our test data. However, if I open the drawer and click on the Define Categories menu, we can see that the navigation is enabled in the wireframe. Unlike a UI prototype, I am not stuck on a single screen. If I type a new category and click Add, however, nothing happens. Let's fix that in 2 steps. First, let's open the Define Categories screen, and in the onPressed Add Event handler, let's add a wireframe event. As you can see, it takes a widget ID for the widget that caused the event and an optional piece of data. In this case, I am passing in the root parameter. It also has an onSuccess handler. We will call the onCreatedCategory function, which just clears the contents of the text field by updating the root parameter. This wireframe event does nothing in debug or production mode, or in a UI prototype, but in a wireframe, it causes the wireframe's body function to be invoked. Let's open the wireframe definition and add some code to handle the wireframe event in the body function. This code just tests whether the event is from the DefineCategoriesScreen and Button Add widget. If it is, it takes the current text from the screen's root parameter, which we pass to the wireframe event, and uses it to construct a new category. It then revises the category's root of the state view by adding the new category, and tells AFib to update the state view with that new root. So, the way to think of shared global state in a wireframe is just that there is a single state view shared among all your screens, and you can update it from within the wireframe function. Now, again, because this wireframe is test code which is captured at startup time, we need to refresh the app. To avoid having to navigate to the wireframe each time, we can open the prototype.dart and set the startup wireframe. Then open the to-do config file and change the environment to startup in wireframe. Then, when we refresh, we start up directly into the to-do list screen for our wireframe. We can navigate back to the Define Categories screen via the drawer, and this time, when we click Add Category, we can see that the category gets added to the list because the state view is now being updated with a new category. In addition, the state view is shared between screens, so if I return to the to-do list screen and click the plus button to add a new to-do item, we will see that the kids category I just defined shows up in the list of categories. Let's quickly do the same thing for the Save button on this screen. We will open the EditTodoItemScreen and add a wireframe event in the EditTodoItemScreen's onPressed Save handler, which passes the root parameter to the wireframe event. In the onSuccess handler, we will call onFinishedSave, which just navigates back to the parent screen. And in the wireframe itself, we will add a handler which integrates the new or updated to-do item into our state view's to-do item's root state. And if we refresh and add a to-do item again and click Save, we will see that the to-do item gets added to our to-do list. If we edit a to-do item and change its name, adding soon, then click Save, we will see that the same logic causes the existing item to update in the list. Now finally, for demo purposes, I want to start my wireframe on the sign-in page. I can do that by opening the wireframe definition and using the AFSI sign-in screen's Navigate Push Ready function to start on the sign-in screen rather than the to-do list screen. Then I can place a breakpoint in my wireframe body function and refresh the app. And if I click Sign In, we will see that the sign-in page produces its own sign-in wireframe event. If I inspect the context in the debugger, I can pretty easily see that the event comes from AFib Sign-In's sign-in screen and button login widget. Continuing will produce an assertion failure, so let's refresh. From that, I can reasonably guess how to detect that event in this function by adding this code. As you can see, in addition to updating the state view, I can also perform a navigation from within the wireframe. In this case, when the sign-in button gets pressed, I will navigate to the to-do list screen. So now if I restart the app, I will start on the login page. I could type something if I wanted to, but it doesn't matter because the event handler isn't sensitive to what I type. When I click Sign In, I get redirected to the to-do list screen, and from there, everything continues to work as I showed you before. I can go to the DefineCategoriesScreen and add a Kids category. Then I can add a new to-do item to go to the movies and assign it to the Kids category. And when I save it, it will show up in my to-do list. So in this section, we learned that once you have finished prototyping some screens, you can quickly tie together a wireframe which appears to work, with data appearing to move between screens with very little code. Next, we are going to begin converting our prototype into a real production app. You might assume that we will now switch to debug mode and begin developing against our Firebase backend, but we will not. Instead, we are going to continue prototyping the full production version of our app in memory all the way down to the query level using state tests. Doing so makes it easier to continue rapidly iterating our app's design without becoming entangled in data migration issues and the complexity of device APIs on the emulator. Let's start by switching back to normal prototype mode, and then navigate into our state tests. Our project style includes several state tests at baseline. Let's select Already Logged in West Coast, and we will see that it takes us to the home screen with the West Coast user already logged in. Remember, when we click a state test, it executes the app startup sequence and possibly interacts with various SPI calls, and then dumps us into the UI associated with the terminal state of that test. This test's terminal state is on the home page of our original app. Now, let's exit this state test and click on Ready for Login West Coast. This test takes us to the sign-in page. If I click Sign In, it tells me that I have to sign in as the West Coast user. And if I do, I end up on the signed in page. In this section, we will understand the startup sequence that came with our project style, and we will also generate and use a listener query for all the categories associated with our family code. We will start by reading the data we need on startup. Note that the written guide describes several ways to load data incrementally if that makes more sense in your app. This project style comes with a startup sequence, which you saw working at the very beginning of this section, when I showed you that Firebase-based registration and sign-in worked out of the box. Let's see what the project style provided as the startup sequence. You may remember that every AFib app starts by running a startup query. Let's open that query. In this app, it just executes a check sign-in listener query. Let's open that query. This is our first encounter with a listener query, which looks almost identical to a standard query. Listener queries are different in two ways. First, rather than executing once and then terminating, they are assumed to live indefinitely, calling context.onSuccess repeatedly each time new data arrives from some kind of push channel. In this case, Firebase can produce a stream of auth state changes, and we listen to that stream on an ongoing basis. AFib actually keeps track of all the running listener queries in your global public state. Second, your query has a shutdown method. You can manage a listener query via various calls on any AFib runtime context. If you shut down a listener query, its shutdown method will be called. Typically, you would use that method to shut down the listener channel you had established. Okay, so if the user is signed in, we call the static signInQuery.onSuccessfulSignin function. If we navigate into that function, we will see that it uses the user ID from the Firebase credential to load in the user object from Firestore using a listener query. And again, if we open that listener query, we will see that it uses the Firestore API to listen to the document ID for the user, and each time it gets an update, it calls onSuccess with the updated user. If we scroll down, we will see that the finishAsyncWithResponse method will integrate that updated user into our user's root state. Doing so will cause any impacted UI to re-render. Okay, so let's return to the sign-in query. We want to change this code so that it listens to all the categories, to-do items, and users which have the same family code. Let's start by just doing that for categories. I'm going to insert a revised version of this function. The user, not the Firebase credential, contains the family code. So first, I'm going to execute the read_one_user_listener query. Then, in its onSuccess handler, I'm going to access the user and use its family code to execute a read_many_categories_listener query via the composite query. That query doesn't exist yet, so we need to create it. If we switch to the command line, we could create the query using the standard generate_query command. But if we type help and run the command, we will see that this project also has an AFFS:generate command. That command came from an open source AFib-aware library called AFib Firebase Firestore. It is an AFib state library, which can add configuration values, commands, state, and various app hooks to an app, but which cannot provide UI. Like AFib sign-in, this library was already integrated for us by our project starter. If I type help AFFS generate query, you can see that this command provides a variety of ways to generate Firestore-related queries. Let's use it to create our read many categories listener query, like this. Let's open the resulting query. Because this example is fairly simple, and because we have used all of AFib's standard naming conventions and root objects, this query compiles and works out of the box. Here, it finds all the categories that have the specified family code and listens for updates to them. Then, in finishAsyncWithResponse, it integrates the items into the category's root object and updates the state. Now, if we return to the sign-in query, we can just import this query, and we are ready to go. Next, we want to test that our query works. Let's switch back to standard prototype mode and navigate to a state test. We will choose Already Logged In West Coast and click on it. And here we will get an error. The error says that this state test doesn't have any results specified for the read many categories listener query, so AFib doesn't know what to do. That isn't a surprise since we just created that query. In the next section, we will understand how to resolve that error. We saw that this project style came with several different state tests. Currently, they will all fail because they don't know how to handle the new read many categories listener query. In this section, we will understand the meaning of extending one state test with another. We'll see how to specify a test response for our new query, and we'll understand that state tests are not just tests, but are also a prototyping tool. Let's start by switching to the command line. State tests are a bit different because they are typically organized using high-level concepts like workflows or areas of your app. If we looked back at the project style, we would see that it initialized our state tests using this command. Despite the syntax, this doesn't generate a class, but it does follow the same pattern for file location. So let's open the startup state test file, which is under Test and State Tests, and we will see that it starts with the Already Logged In West Coast state test, which provides results for a lot of our existing queries, our startup query, our check sign-in listener query, our read_one_user_listener query, and so on. If we look at the Ready for Login West Coast test, we see that it extends Already Logged In West Coast and overrides the results for the check sign-in listener query, returning a user credential root that is not signed in rather than one that is. It also provides a dynamic query result for the sign-in query, which requires the user to enter the West Coast user's email, returning an error otherwise. The exact meaning of state test extension is subtle and is better covered in the written guide, but roughly speaking, when one state test extends another, it inherits all of the query results of the parent state test, except those that it overrides. The first implication is that this state test will end up on the sign-in page on startup, rather than on the to-do list screen, because that is how our app responds to a not signed in user credential. That is why, when we clicked on the Ready for Login West Coast state test, we saw the sign-in page. However, if we enter the West Coast user's email and click Sign In, it will navigate to a home screen that is populated with the same test data as in our already logged in state test. That is because it inherits all the other query results from that state test. The second implication is that we only need to add the Read Many Categories listener query to our root test in order to restore all the tests to working order. Let's return to that test, and we will add a result for our Read Many Categories listener query. The Read Many Categories listener query expects a list of categories as its response, so we will go into our test data, and just to differentiate our examples a little bit, we will create a new list of 3 category items with a test ID, the original 2 plus a trips category. Then we will refresh the app, and the state test will work, except that it's still taking me to the original home screen. Let's return to our sign-in query and change the onSuccess handler for our composite query to navigate to the to-do list screen rather than the home screen. Now we will refresh, navigate into the state test one more time, and see that we end up on the to-do list screen as expected. If we open the drawer and go to Define Categories, we will see that it has 3 categories, including our new Trips category, which we defined as the response to our Read Many Categories listener query. Okay, so we will want to start listeners for both our users and to-do list items in this family. There is nothing new to that, so I'm going to do that off screen. In each case, I will generate a listener query. Because it's simple, it will work out of the box. I will execute it from my onSuccessful sign-in method as part of the composite query. And then finally, I will add results for it in the root state test. While I'm doing that, I want to note 3 things. First, the ability to extend state tests makes it possible to preserve the data that your existing tests assume while introducing new extended tests with a richer data set that you can use to exercise additional functionality. For example, perhaps I have a bunch of state tests that assume I start with 3 to-do list items. Then I decide that I need a test that exercises scrolling in the list, which requires more to-do items. If I changed my existing test data, some of my existing tests will fail. But if I introduced a new state test that extended my previous state test and overrides the response to my Read Many To-Do Items listener query with more to-do items, then my new test can have more to-do items while my existing tests continue to have 3. But it's not like I need to re-specify all the query results. I just override that one query. Second, as your app is more fully developed, state tests are a great place for prototyping UI. If I am starting a new screen from scratch, I will typically use a UI prototype. But if I am modifying an existing UI element, I often find prototyping in the fuller context provided by the state test to be more productive. And finally, just note that as I develop differentiated state tests, I am also developing differentiated prototype development environments. I find that I end up hopping around to different state tests as I prototype because it allows me to test my new code in different data states easily. I find this to be a more reproducible, efficient way to maintain prototype environments than attempting to maintain a full prototype backend to develop against. Okay, so I added the additional queries during the startup process and the additional query responses to the state test. And now, when I select the already logged in West Coast state test, I get a version of the app which has some categories and some to-do items already. And if I exit that state test and log in via the Ready for Login state test, I'll find that it also works as expected and is populated with the same data that is inherited from its already logged in West Coast parent state test. The other thing we still need to do is write both categories and to-do items when they are created or updated. In this section, we will learn how to implement queries that write data and how to implement dynamic query handlers that simulate the writing of data in a state test. Let's start with categories. On the command line, I'll use the AFFS generate command to create a write1 category query. It will have the category to write as a member variable and a category as its response type. After we run the command, we will open the resulting query file, and we will see that it writes the category to Firestore in start async, and then integrates the result into the category's root state. Because this is a simple case, the query works out of the box. Now, let's open the DefineCategoriesScreen, and in the same location where we introduced our wireframe event, let's execute our write1 category query. And in its onSuccess handler, let's call the onCreatedCategory to clear out the category text. You can now see why I put this in a sub-procedure. It is reused by both the wireframe event and the query. At this point, if I go into my state test and try to add a category, you can hopefully predict what will happen. It will complain that the state test doesn't provide a response for this query. So let's open the state test, and in this case, we will create a dynamic query handler. That handler will check if the category ID is new, and if it is, assign a new stable ID to it. Then it will call onSuccess with the revised category. That category is the value that will be passed to the query's finishAsyncWithResponse method. Now let's open TodoConfig and change it to start directly into a state test. And in prototype.dart, start into the already logged in West Coast state test. Now, if I refresh the app, navigate to the DefineCategoriesScreen, and add a kids category, it will be added. If I navigate back to the home screen, then to the Add To-Do Item screen, the new category will be available for use there. So the handling of a write1 to-do item query is no different. I'll do it off screen. Just as before, I'm going to generate the query, then call it from the Save button handler in the EditTodoItemScreen. Then add a dynamic response handler to my root state test. And when I do, we will see that I can create a new to-do item, and it will show up on my to-do list screen, or I can edit an existing to-do item, and my changes will be saved on the to-do list screen. You may remember that we can complete a to-do item by swiping left on it. We haven't implemented that yet. Let's go ahead and do that now. In this section, we will learn that create, read, update, delete queries tend to be highly reusable, and therefore that the query model scales reasonably well in a typical app. We will also see that our SPI hides the introduction of additional complexity from our UI code. And finally, we will see how we can simulate and manage latency in AFib. While I'm on the topic of the query model's scalability, I'd just like to note that although this example is simple, AFib's inciting app uses queries to encapsulate interactions with streaming media, device purchase APIs, and background threads, which Dart calls isolates. My experience so far has been that the query model scales conceptually as well. At this point, the implementation for completing the to-do item should be pretty obvious. First, we will use generateAugment to add a bool to our to-do item, indicating whether it is completed or not. Then, we will need to go through our test data and navigate push calls and fill in that value correctly in each case. I'll do that off screen as it isn't very interesting. Then, we will open our to-do list screen and modify the accessor on our SPI called pending items so that it returns only the to-do items which are not completed. Finally, in the TodoListScreen's SPI's onDismissedItem method, which at this point is just a log statement, we need to revise the to-do item's completed state and write it to Firebase using our existing write1 to-do item query. Our state test already has a dynamic handler for that query because we already used it to save new and edited to-do items, so we don't need to change our state test. Now, we will need to refresh the app because the in-memory versions of our to-do items don't yet have the completed member variable, which will cause an assertion failure. Once we do, if we swipe left on a to-do item, it disappears. While we are here, let's talk about query latency. In a state test that is running in the UI, AFib simulates latency. By default, each query takes 200 milliseconds. However, if we open the todo config file, we can change the simulated base latency from 200 milliseconds to 3000. Then we need to refresh the app. Now, when I swipe left on an item, we will see that the item itself disappears almost instantly. That is because of the way Flutter's disposable widget works. It keeps track of the fact that the child widget has been disposed and refuses to render it even though it is still present. But the header title for the now empty category takes 3 seconds to disappear. That is because the completed version of the to-do isn't integrated into our state until the query completes, which is now 3 seconds later. Let's watch it again. Watch the to-do disappear immediately, but the category header linger for 3 seconds. AFib has an easy way to address the latency issue. Let's open the to-do list screen and look at the execution of the write one to-do item query. In addition to onSuccess and onFailure handlers, each query comes with a special onPreExecute response handler. You can use this to supply an initial query response that should be written to your state via the finishAsyncWithResponse function synchronously. And then, when the actual response comes through from Firebase, it will be processed again. Consequently, this only works when the update is idempotent. But in this case, we can just return the revised to-do item we already have as our pre-execute response. This response will be written into our state synchronously. Note that this query's onSuccess handler already displays a log message saying the query completed. Let's refresh the app to reset our to-do list. And when I dismiss a to-do item, you'll see that the header now disappears instantly. That is because our pre-execute response is updated in our state synchronously. If we zoom in on the debug console, you will see that our success handler executes twice. Once when the pre-execute occurs, and then 3 seconds later when the latency expires and the actual query completes. You will also see that I can differentiate those cases in the handler using context.isPreExecute. Now let's dismiss one more item, and you will see that the header disappears almost immediately, although the log statement shows that the query completes almost 3 seconds later. I have not explicitly mentioned error handling during this tutorial. I want to very briefly point it out in a few places so that you see how it works. If we open the sign-in query, you can see that in addition to the context.onSuccess, the startAsync method has a context.onError method for reporting errors. In this case, an error can occur when a user enters an invalid password. If we scroll down, you can see that there is a finishAsyncWithError method which parallels the finishAsyncWithResponse method. In this query, it uses AFib signin's LPI to update the sign-in screen status message with an error. Most queries do not have a finishAsyncWithError method. If I open the write one category query, I see it can report an error in startAsync. Firestore reports errors for network issues and authorization failures in this case. But if I scroll down, I see that it doesn't override finishAsyncWithError. In that case, AFib will defer error handling to the default error handler defined in TodoDefineCore.dart. Let's open that file. And we see that during setup, we provide a default query error handler. AFib provides one, AF default query error handler, which shows a dialog box describing the error. This is also a good place to set a breakpoint if you have an error in an asynchronous query that you are having trouble tracking down. Finally, if we open the startup state test and search for onError, you can see that a dynamic query handler in a state test can return an error via context.onError, paralleling the code you see in startAsync but in a test context. This is how the Ready for Login West Coast state test forces you to log in as the West Coast user. Or, if you always want a query to produce an error, you can use testContext.DefineQueryResponseError. If I do that and then navigate to my Ready for Login West Coast state test and click Sign In, I'll see that I get the error message back in response to the sign-in query. The project style we used provides state tests for several different sign-in and registration scenarios. If you end up using AFib, you can study those scenarios and begin extending them with meaningful test cases in your actual app. In this section, we are going to work on implementing a more robust state test in the existing Manipulate After Sign-In West Coast state test. Before we start, let's try running our tests and see what state they are in. When we run the tests, we get an error message in the Ready for Login West Coast state test, which says that no root parameter was found for the homepage screen. If I study the stack trace, I see that it was on line 160 of the startup state test file. Let's open that file, and we will see that it is trying to verify something on the home screen. Earlier, when we talked about state tests, I said that these lines weren't moving you to the home screen. They were validating that you were on the home screen in the app. But the home screen was the screen the app came with, which just showed the user's login information. Our app no longer goes to that screen. Instead, it goes to the to-do list screen. That is what is causing the error. So I'm going to go through this file and remove all references to the home screen, which is no longer relevant. And for efficiency, I'm going to change a reference to the zip code, which we removed, to the family code. And having done that, if we run the tests, we will see that they all pass. Now, in preparation for testing, let's focus on the state test we are going to modify. Let's select its ID and paste it after test on the command line, then run the command to run just that test. Let's also open TodoConfig and choose to start up directly into that state test, and then open prototype.dart and specify the test we are working on. And if I refresh the app, we will see that the terminal state of that test is currently on the to-do list screen with a few to-do list items. If you've ever heard the saying, slow is smooth and smooth is fast, that is how I develop state tests. I progress through the scenario I want to develop one step at a time, verifying that I get the results that I expect at each step. I find doing so faster than writing a giant state test and then trying to figure out where in the test I forgot to do something or got some unexpected result. I'm going to start by pasting in some shortcuts for all the different UI elements I will use. Note that AFib maintains this shortcuts object for you. The shortcuts object just encapsulates certain data types and IDs which you would otherwise have to repeat throughout the test. Also note that the definitions object is the outermost context of a state test, and that I can use it to look up test data if I need it, as I am doing here. Now, let's add a section that verifies the initial state a bit, then taps the filter icon using the TodoListScreen's SPI. If I refresh, I see that the OrganizeByDialog is showing. Next, let's add a section that accesses the dialog's SPI, changes it to be organized by user, and then closes the dialog. Let's refresh again, and now we see that we are back on the home page, which is organized by user. Let's switch to the command line and run our test there. And we will see that we now have some passing validations. Now we will add the next section, which interacts with the bottom navigation widget, which is an AFib-aware widget. As a result, it needs a launch parameter. Note that the launch parameter would usually be specified in your UI rendering code, but your UI rendering code is never called in a state test. That is why we need to specify it in the state test as well. One thing we could do is find the UI code that currently creates the launch parameter and copy and paste it. But a better solution is to move that code from the UI code up into the SPI. I will open the to-do list screen and do just that. I'll create the root parameter in an SPI method, then implement that SPI method to return the root parameter. Then I'll return to the test, and I'll get the launch parameter from the parent screen's SPI. There is a lot more flexibility in specifying child widget parameters than I have explained here. The topic is covered more fully in the written guide, but as a general rule, you want to create launch parameters for AFib-aware widgets in an SPI method. Okay, so that said, I can now access the widget's SPI and use that SPI to open the menu drawer. In the next section, we will just call the drawer's onPressDefineCategories method. One thing to note here is that when I do just one thing on a screen, AFib provides a shortcut build method which takes you directly to the SPI rather than creating a screen context and then executing a build. If I refresh, I will see that I am on the DefineCategoriesScreen. Then I will write the code that adds a kids category, which changes the value of the text field, then presses the add button. And if I refresh, I'll see that the kids category is now present. However, let's go back and stop my state test just after I enter the kids text, using execute debug stop here. Remember, that stops the state test and dumps me into its UI at that point. And then let's open the DefineCategoriesScreen file and comment out the context.updateText field call. Remember, I told you that that call was necessary to synchronize text when we jump into a UI as part of a state test. And if we refresh, we will get the assertion failure that I told you about. It is saying that the state of the Flutter text controller is out of sync with that in our root parameter value. Let's re-enable that code and refresh. And we will get what we expect, which is kids typed into the category edit at the bottom. Okay, so let's remove that execute debug stop here call. If you leave that in, by the way, it will produce an error in your command line test, which prevents you from unwittingly disabling a big part of a state test. Then I'll add test code to the state test that clicks the Add button on the To-Do List screen, and then uses the EditTodoItemScreen's SPI to create a Go to the Movies to-do item. And in the next section, where I add the to-do item, it's worth noting that I can validate that my category search functionality is working on the Edit To-Do Item page. I can change the search text, then verify that we found the expected categories. If I had some kind of complex fuzzy matching logic, I would probably create a separate state test just to drive this aspect of the UI and validate a bunch of scenarios. Let's comment out the save press briefly. We will refresh and see that the text of the category search widget is filled in, and the search results are shown as expected. But now, let's briefly open the Edit To-Do Item screen. Okay, let's re-enable the save press. Let's refresh again, and we should be back on the To-Do List screen, but with a new to-do list item for going to the movies. Then, let's press the filter icon again and go back to the Organize by Category setting, and refresh to verify that it worked. Now it's easier to see our new Go to the Movies item under the Kids category. Then, in the state test, we can verify that the new item is present on the screen, dismiss the item, and refresh once more. We see that the Go to the Movies item is now gone, as it has been completed. Finally, let's go back to the command line and rerun our tests, and we will see that we have more passing validations. Okay, so that is how I would implement a simple state test. I think it covers a lot of functional ground in relatively few lines and acts at a level that is fairly easy to understand. This section was meant to explain implementing UI tests, but the truth is, my heart is just not in it. I hate UI testing. AFib does support attaching UI tests to your UI prototype screens. I will cover it in the written guide. But in general, I think UI testing is very inefficient for at least 4 reasons. First, accessing and manipulating specific widgets is tedious. You have to declare the widget IDs in your UI code, then reference them in the test. You have to worry about scrolling and what is visible on the screen, which is an inherently asynchronous process. Second, widgets are a poor format for validating state in your app. They are designed to be viewed by people, not validated by code. I think most UI tests are an imperfect way of validating business logic better validated in a state test. Third, rendering UI is asynchronous, and asynchronous tests are difficult to debug and often produce difficult to reproduce errors. And finally, my personal experience is that UI code is not where the bugs live. They are more often found in business logic. Even if there are bugs in the UI code, my personal experience is that you can write a lot of UI tests and then not catch the bugs that actually arise. If you have a relatively stable UI and you want to write UI tests, I recommend you really think through what you are testing. Be certain that you cannot simultaneously simplify your UI code and avoid UI testing by pushing logic into your SPI. If you have UI tests, they should really be limited to testing that the correct widgets are realized from a given SPI's state, and that interacting with specific widgets produces the expected state change events. I want to briefly cover one more testing topic here. State tests do not cover serialization logic. I believe tests for serialization logic belong in unit tests. AFib has its own way to create unit tests, which is accessible from the generate test command, and which provides easy access to your test data and AFib's standard test output. Did you ever see the movie Before Sunset, where the movie clearly needs to resolve a critical question, and you keep getting closer and closer to the end and the question is still unresolved and still unresolved, and then finally it gets resolved in like the last 10 seconds of the movie? Well, this tutorial is a little bit like that. Aside from making sure that we have the correct security rules on our Firestore database, which I'm not going to cover, and either upgrading our original user to contain a family code or deleting it, otherwise we'll get a null pointer error in our serialization logic, the app is ready to work. Now we are going to switch to debug mode and refresh it. Now we are running with real queries against our Firestore database. There is no test data or state tests involved. And I'm going to register a new user, and I'm going to add 2 categories, and I'm going to add 2 to-do items. And if I open the Firebase console, I will see that the auth credential and the user and the categories and the to-do items are all in Firebase. And if I register a second user on an Android device with the same family code, and I add a to-do item, it will show up in real time on the first device. And if I edit an existing to-do item, the change will show up in real time on both devices. And if I go into my user settings and change the username from Catherine to Kate, the name shown on the to-do items on the other device will update in real time as well. So there we go. Just like before sunset, we talked and talked and talked, and just when you thought you couldn't stand it anymore, it all worked out in the end. It would have been nice to end it that way, wouldn't it? But just like before sunset, when you stop to think about the ending, things might not wrap up quite so neatly as you might initially like to believe. For the record, Before Sunrise pays those complications off and enables the entire trilogy to say something really profound about love and marriage in the third movie, Before Midnight. However, if you are interested in playing with AFib more, the next place to go with AFib is reading the written guide, which will help you get started and cover a lot of the details that I omitted here. In particular, the section titled Transition to Coding in AFib will interactively walk you through the essence of this tutorial. Each of its sections is designed to quickly reinforce what you learned here, while being simpler and more efficient than replicating the full content of this tutorial. You can also submit bugs and access a discussion forum on GitHub. GitHub also has a pinned bug titled Exit Interview Gave Up on AFib? Please explain why here. If you try AFib and run into problems that cause you to abandon it, I'd really appreciate your logging what happened in that bug. It will help me improve the experience for future developers. I may also add some additional videos on this channel in the future, so you can subscribe to it if you want to hear about those. If there are any important updates which I publish subsequent to this video, I will link them in the description, so you might want to check that now. I'm not on any social media platforms, so YouTube will be your best bet for notifications related to AFib, if you want them. As of this recording, the amount of time I've spent on this tutorial, and AFib itself, seems quixotic or perhaps Sisyphean, but I'm curious to see where it leads and if other people can get some value from it. If you somehow made it to the end of this tutorial, I'm Chris, the creator of AFib, and I'm truly grateful that you're here.